Hello all, welcome to this session. In this session, I am going to answer software testing interview question 251. That is, what is release candidate, that is RC phase of the software? Let me answer. So what is the RC phase of the software? Software, while being developed or during or while getting released into the market, goes through several phases. The different phases the software will go through are pre-alpha phase, which is the first phase of the software. After pre-alpha phase, we have alpha phase, then beta phase, then release candidate phase, which is the fourth phase of the software. And finally, we have the stable phase of the software. Okay. The last and final phase of the software is stable phase. Okay. These are the 5 phases of the software. So now coming to the question, what is release candidate phase of the software? That is the what is the this particular phase, release candidate phase of the software. This is the fourth phase of the software, guys. Okay. First of all, this is the fourth phase of the software where beta testing will be performed. Okay. In this phase, beta testing will be performed. So I'll go deep into this, why beta testing will be performed and all. Okay, how beta testing will be performed here. As part of this release candidate phase of the software will be released to the customers. Okay, the software will be released to the customers for testing purpose and collecting the feedback from them. Okay, so while releasing the software to the customers for testing purpose, there are different release names. Okay, different companies while releasing this software in this release candidate phase to the customers for testing purpose for collecting the feedback will call these release names with different names. What are the different names? RC release they may call. They may call that as silver release. They may call that as gamma release. They may call that as delta release. Any of these names. Okay. The company may use for naming the release of the software to the customers for testing purpose and collecting the feedback in the RC phase, that is release candidate phase of the software. So to understand the release candidate phase well, we need to understand the previous phases of the software. Coming to the pre-alpha phase, which is the first phase of the software, here testing will not be performed. Here development will start. Okay, development has just started with the help of the whatever the requirements or any documents. Okay, here testing will not start, and here no software will be released into the market. Okay, here no software will be released into the market. This is the pre-alpha phase, and the next phase is the alpha phase. Okay, here formal testing will start. Till now there was no formal testing, but in alpha phase the formal testing will start. This is the second phase of the software where formal testing will start. Here in the pre-alpha phase, even developers will not perform testing, guys, but in alpha phase all the levels of testing will be performed. That is, there are different levels of testing, right? Unit testing, integration testing, system testing, and user acceptance testing. All these levels of testing will start in the alpha phase of the software, while developers will perform first unit testing, followed by the integration testing, where software testers will perform system testing. Okay, and finally, user acceptance testing will be performed as the last level of the testing in the alpha phase. But the problem here is user acceptance testing will not be performed completely. Only one part of the user acceptance testing will be performed in the alpha phase. That is, alpha testing will be performed by the client side business people, not end users. Okay, client side business people who know the business well and who actually interact with the customers or end users and know the needs and expectations of the end users, right? They will be coming with a checklist and traveling to the developer side and sitting side by side. They will ask the developers to modify the software according to the user needs and expectations. Okay, so whatever the knowledge they have, they will use that for the and help the developers in modifying the software or modifying the software according to the user needs and expectations. Here software testers also will support this team. Okay, and here all the features need to be completed, guys. Okay, whether it can be from the requirements or whether whatever the client side business people given needs and expectations of the user accordingly, all the features need to be completed. No more features need to be added in the upcoming phases. Okay, like that it will be there. Here software won't be released yet. Okay, still in alpha phase, despite of doing all these levels of testing, also software will not be released into the market. Okay, here also software will not be released. The reason behind that is beta testing is not performed. Only up to alpha testing is performed in the alpha phase. Where is beta testing? Beta testing is not yet performed, so that beta testing will be performed in the firstly. Okay, Firstly, the beta testing will be performed in the beta phase of the software. This is the third phase of the software, where software will be for the first time released into the market, that is to the end users or customers, but with an intention of testing purpose only, not for selling and usage purpose. Okay, your software will be released to the customers for testing purpose and for collecting the feedback from the users. Okay, not for the real real release. It's not a real release day, right? It's not a real release. Okay, release is with an intention, like the customers can use in the real environment and give us back the feedback. Okay, with the help of the feedback, where the company want to improvise the software according to the user needs and expectations. Okay, that's what is the purpose here. So here, that's what is a beta testing, guys. Okay, hence beta testing will be done by the end users or customers of the software. Okay, but there are two levels. Okay, there are two ways of the company may decide to release the software for beta testing into the market in two models. Okay, one first model is open beta release. Okay, first model is open beta release. In open beta release, where they can release, where the software will be released to the entire public, all the complete public. It will be released for beta testing. The complete public may use it and provide the test it and provide the probable feedback. Okay, possible feedback. In closed beta release, they don't want to release the software to the entire public. Rather, they want to select the limited or closed group of end users or customers. Only limited customers or limited end users, only these people will use and give the feedback. Okay, so that is beta phase. Okay, so that is beta phase. But once the feedback comes back in the beta phase, the story is not ended. Okay, the story is not ended. The company is still not satisfied in the beta phase. So whatever the feedback the company has received as part of the beta phase, by releasing the software to the end users or customers for testing purpose and collecting the feedback, that based on that feedback, again the development team will work on that, will modify the software according to the feedback received from the end users or customers in the beta phase. Okay, and finally, once the software becomes stable again, okay, and all the feedback received from the users, end users or customers is incorporated into the software, then the fourth phase of the software will start, that is called as release candidate phase. Okay, to understand the release candidate phase, we have to first understand what is pre-alpha, alpha, and beta phase. That's the reason I explained all this story. Okay, so whatever the feedback that is collected, that is now incorporated into the software according to the user needs and expectations with the help of the developers and testers. And okay, this is the last. This is the fourth phase of the software, and here again beta testing will be performed. Don't think that beta testing will be performed only in beta phase. Beta testing will also be performed in the release candidate phase. Okay, in that stable version of the software, wherever the feedback received from the end users or customers is received from the beta phase is incorporated. Again, the beta testing will be performed in the same way. Again, open beta release will happen or closed beta release will happen based on the company decision. In open beta release, as you already know, complete public, the software will be released to. In closed beta, the software will be released only to the closed group of end users or customers. Okay, closed group of end users or customers. So here software will be released to the customers for testing purpose again. Okay, beta testing is the same thing, right? So for testing purpose again, but this time, what is the difference between this beta testing and this beta testing? In this beta testing, uh, till now we have not received any end users or real customers feedback. For the first time, we have received the feedback by releasing the software into the market for the end users or customers in beta. But this time, uh, the software the software will be kind of bit more stable and bit more convincing for the end users and customers, because we have already collected the feedback in the beta phase and incorporated into the software. But as a second chance, again we are going to provide beta testing chance to the end users or customers by releasing the software to the end users or customers either in open beta way or closed beta release way. Okay, on to limited end users or complete public. Fine. And while releasing the software for beta testing, we call that particular software release with different namespace. Okay, that is RC release we can call. Okay, so in the RC phase, if we are releasing the software to the end users or customers for testing purpose and for collecting the any other extra feedback, okay, we call that release as RC release, or we can also call that as silver release or gamma release, delta release. Different companies will call this release to the customers or end users for testing purpose and collecting feedback with different names like this. Okay, so this is what is release candidate phase. RC phase of the software. So hope guys you got the full picture of what is the release candidate phase of the software. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 252. That is, beta testing will be performed in which phase of the software? Let me answer. So, the simple and straightforward answer for this question is beta testing for software will be performed in two phases, not one phase. That is beta phase and RC phase. Okay. So software goes through a lot of phases, right? While during development or while during or getting released into the market, software has to go through several phases. The different phases the software will go through are pre-alpha phase, which is the first phase, followed by alpha phase, then beta phase, which is the third phase, then release candidate phase, RC phase, which is the fourth phase, and final phase is a stable phase. Okay, these are the different phases of the software, and software will go through. But in all these phases, in which phases beta testing will be performed? So as I already mentioned, beta testing will be performed in beta phase. Not only in beta phase, beta testing will also performed in the release candidate phase, RC phase. Okay, in both these phases, beta testing will be performed. Let me explain in detail. In pre-alpha phase, no testing will be performed, guys. Okay, the development will start. Okay, where the developers will start developing the software with the help of the requirements. Okay, the BRS document or whatever the documents they have. Here, no testing and no release will happen. And coming to the next phase, that is alpha phase, here is a phase where testing will start, but without beta testing. Okay, in this phase, beta testing will not be performed. Except beta testing, every testing will be performed. All the different levels of software testing will be performed except beta testing in alpha phase. So this is the second phase of the software where formal testing will start, where the developers will start testing, testers will start testing. Okay, user acceptance testing will also be performed, but except beta testing. So developers will first perform unit testing followed by integration, whereas testers will perform system testing where they will test the entire system is developed according to the requirements as a whole. Okay, then the last level of the testing, that is user acceptance testing, will also be performed by the user acceptance testing will also be performed in this alpha phase, but only one part of the user acceptance testing, that is alpha testing, will be performed where beta testing won't be performed. Okay, beta testing will be performed in the next phases. So as part of alpha testing, the client side business people who knows the business well and who generally interact with the end users and customers, who generally know the needs and expectations of the users, okay, will perform the testing and will come up with a checklist of the needs and expectations of the users that developers have to modify the software accordingly, and testers will also support in this phase. But beta testing is not performed. Okay, so here all uh, the software, all the features of the software according to the client given requirements or this client side business people given needs and expectations of the user need to be completed. Okay, then only alpha phase will be completed. Here also the software won't be released. Okay, software won't be released here also, guys. Next one is beta phase. Okay, in beta phase, which is a third phase of the software, for the first time the software will be released into the market. But here there is a twist. Okay, software will be released into the market to the end users and customers with a twist. That is, this is not for real use of the software. The software will be released to the end users and customers only for testing purpose in this phase and for collecting the feedback. Company behind the software want to collect the feedback. With that reason only it is releasing the software into the market, guys. Okay, which is called as beta testing. And the company may go for beta testing by releasing the software into the market to the real end users or customers for testing purpose and collecting the feedback in two models or two ways of releases. Okay, they might either go and decide with open beta release where they will completely release the software to the complete public, to the entire public. They will beta release the software for beta testing. Okay, so whereas closed beta, only for limited group of end users or customers, they will release the software for testing and for collecting the feedback. Okay, this is the beta phase. Once the feedback is collected as part of beta testing done by the end users and customers in the beta phase, okay, again the developers and testers have to work together and come up with a more stable application which actually matches the needs and expectations of the users based on the feedback received from the end users in the beta phase. And in the release candidate phase, RC phase, okay, which is the fourth phase, again they will release the software, guys. Again the software which is kind of more better this time, which has more benefits to the end users needs and expectations, which has given the importance to the end user needs and expectations, will be released to the same end users and customers. This time also it's not a real release, it is also a tricky thing for testing purpose and for collecting the feedback for the second time. Okay, still the company don't have the confidence to release the final version of the software into the market in this RC phase also. Here also beta testing will be performed similar to the beta phase. In beta phase, beta testing will be performed by end users and customers for testing purpose and providing the feedback. In release candidate phase also, the software will be released into the market for testing purpose by the end users and customers for collecting the feedback only. Okay, again the same type of releases, open beta release and closed beta release will happen here also based on the company's decision. And but there are different names for this release candidate phase releases. Okay, okay, so we generally call these releases as RC release. Sometimes some companies may name it as RC release, some companies may call it as silver release, some companies may call it as gamma release, some companies may call it as delta release. Whatever the reason may be, the question here is in which phase of the software beta testing will be performed. Okay, in both the phases, guys, that is in beta phase and release candidate phase, beta testing will be performed. That's the answer. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 253. That is, do we release the software during RC phase, that is release candidate phase of the software? Let me answer. So during the RC phase, that is release candidate phase of the software, do we release the software? The answer is yes, but it's not the real release. Okay, it's a different release. Let me explain everything in detail. So software goes through several phases while being developed or while getting released into the market. Software has to go through several phases like pre-alpha phase, beta phase, release candidate phase, RC phase, that is, and finally stable phase. These are the different phases software will go through. Coming to the release candidate phase, will we release the software into the market? The answer is yes. But what is the purpose of releasing the software into the market, that is to the end users or customers, is different. That is, here is the fourth phase of the software where software will be released into the market to the end users and customers. So the answer is yes. But the purpose is so that the end users can test it. Okay, use and test it and give the proper feedback back to the company. Okay, but this is not the real release. Same thing happens in the beta phase also. Okay, here in beta phase also, the software will be released to the end users or customers for testing purpose with an intention of collecting the feedback for them from them. Okay, same thing happens in release candidate phase. After incorporating the feedback that is received in the beta phase, the developers will do the changes in the RC phase before releasing the software. A kind of software which is incorporated with the feedback received in the beta phase will be released into the market for second chance. Okay, a second beta testing will be performed where again if any other feedback is left out, okay, the user needs or expectation kind of feedback is left out, that feedback will come back. Here this is not the real release, guys. Okay, this is not the real release. This is just a release done by the company to get the feedback from the users. Okay, so in beta testing will be done and the release also will be done in two manners. Company may decide to release the software in RC phase in two ways. Either it can go for open beta release or it can go for the closed beta release. In case of open beta release, the software will be released to the end users or customers, that is to all the complete public, guys. Okay, to the complete public around the globe it will be released. But in closed beta phase it will be only released to the limited number of people. Okay, limited number of end users or customers or closed group of end users or customers only it will be released, and they will use the software as if they are using in real time. And if any feedback is there, that feedback will be received from the public back to the company. Okay, so to get more confidence on the software, whether the software is meeting the end users needs and expectations or not, the second level of beta testing will be performed in the release candidate phase, and the release will be done in the open beta release or closed beta release. And there are few names for the release, guys. Okay, there are some names for this release, that is it can be called as RC release, it can be called as silver release, gamma release, delta release. The software that is released to the customers or end users for testing purpose to collect the feedback can be called as RC release, silver release. The name of gamma release or delta release, it will be released into the market and the feedback will be received from the customers. So hope guys you got the answer for this question. Do we release the software during release candidate phase? Yes, the answer is yes. But for testing purpose and for collecting the feedback from the end users and customers to know their needs and expectations, it is being done, but it's not the real release. Okay. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye-bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 254. That is, what is RC release? Let me answer. So RC release is the release of the software in the RC phase of the software. Software goes through several phases while getting developed or during or while getting released into the market. Software goes through several phases. RC is one of the phase of the software where RC release happens. Let me explain in detail. You see, the first phase of the software is pre-alpha phase, and the second phase is alpha, then followed by beta phase, then release candidate phase, that is RC phase, and finally we have the stable phase. Okay, these are the different phases of the software. In the release candidate phase of the software, okay, the software will be released into the market with an intention of getting tested by the end users or customers and collecting the feedback from the users. Okay, it's not the real release, guys. The software is not really released. Okay, the software is released with an intention of getting it indirectly tested by the end users when they are using the software and thereby collecting the feedback from the end users. Okay, so with this feedback, the company behind the software will know like what are the needs and expectations of the users. Okay, so this is the fourth phase of the software where software will be released to the end users or customers, but this is not the real release. The release is intended with an intention of getting it tested by the end users. Okay, when the real users use the software, automatically it will be tested in different conditions and different circumstances, and lot of feedback will be received for the company. Okay, once the feedback is received, the software will be modified according to the user needs and expectations. Okay, that is the advantage. So here this kind of testing which is indirectly done by the end users or customers when the software is released into the market is known as beta testing, and the company may decide to release the software in two formats, any of the two formats of releases, either open beta release or closed beta release. In open beta release, the software will be released to the entire public, that is complete public. Okay, so that more feedback can be collected. Whereas in closed beta, only for a limited or closed group of end users or customers, it will be released. Okay, and here also the indirectly testing will be done and the feedback will be received by the company for the benefit of the company. Okay, so what is this RC release? Okay, as I told you right here, whenever we are releasing the software to the real end users or customers for indirectly testing purpose and collecting the feedback, okay, there are different names for these releases. Okay, different companies call this release as different release names. Okay, so some people call that as RC release. Okay, this is what is RC release, guys. Okay, as the question speaks, what is RC release? Okay, releasing the software in the RC phase of the software, that is release candidate phase of the software, is called as RC release. That's it. Okay, so we can also call it has other names like silver release, gamma release, delta release also. Okay, so hope guys you got the answer for this question. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 255. That is, what is silver release of the software? Let me answer. Silver release of the software happens in RC phase of the software, that is release candidate phase of the software. Software has several phases or goes through several phases. That is, while getting developed or during or while getting released, software has to go through several phases. There are 5 phases of the software. That is, first phase is pre-alpha phase, followed by alpha phase, then beta phase. RC phase, that is release candidate phase, comes in the fourth phase, and final phase is stable phase. These are the 5 phases of the software. And in the RC phase of the software, that is release candidate phase of the software, the silver release of the software will happen. So what is this silver release? So RC phase, that is release candidate phase, is the fourth phase of the software. Here, software will be released to the end users and customers, but not a real release. It's not a real release, guys. Okay, the release is done by the company behind the software. Okay, to collect the feedback from the end users and customers. Okay, so when this particular software is released into the market to the end users and customers, customers will start using the software. Indirectly the testing will happen, and because of this indirect testing in various situations, conditions, circumstances and environments, lot of feedback will be received back to the company. Okay, and the company also will get to know what are the end users needs and expectations. Okay, these are the advantages of releasing the software in the RC phase of the software. This is not a real release of the software into the market, rather the release is intended with an intention of indirectly the software to be getting tested by the end users and customers, and to collect lot of feedback in different circumstances. Okay, and this kind of testing which is being done by end users and customers because of this release of the software in the RC phase is called as beta testing, and the company will decide to do this release in two formats. Okay, any of the format it can choose, either open beta release or closed beta release. In open beta release, the software will be released to the complete public or entire public, but in closed beta, the software will be released only to the closed or limited group of end users or customers, and indirect testing will be done and feedback will be collected. So there are different names for this release, guys. Okay, there are different names for this release. One of the name is the silver release. Okay, one of the name is silver release. Okay, so if the release is happening in the RC phase of the software, release candidate phase of the software, we can call that release of the software to the customers, which is indirectly for getting tested by the end users and customers and collecting the feedback, is called as silver release. Okay, it's also known as RC release, gamma release, other names are delta release. Okay, all these releases are same, but different names for the same release in the RC phase. Okay, whatever the release that happens in the RC phase of the software to the end users and customers with an intention of indirectly getting it tested and collecting the feedback is called as silver release. Okay, so hope guys you got the answer for this question. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 256. That is, what is gamma release? Let me answer. In RC phase of the software, if you release a software, we can release the software with the name of gamma release. Okay, gamma release is nothing but a release name of the software, which is generally released in which phase of the software? RC phase. So first of all, the software goes through several phases while getting developed, or while or during getting released into the market. Software has to go through several phases. There are 5 phases of the software. That is pre-alpha phase, which is the first phase of the software. Then followed by we have the alpha phase, then beta phase, followed by release candidate phase, which is the fourth phase of the software, RC phase or release candidate phase. And finally, we have the stable phase. In RC phase, that is release candidate phase of the software will be released to the end users or customers for beta testing purpose. This is not a real release, guys. Here, the release is happening with an intention of collecting the feedback. Okay, by having the software indirectly tested by the end users or customers. Okay, the company behind the software is releasing the software with an intention of collecting the feedback from the end users or customers. Okay, so that the company can know the user needs and expectations. This is the fourth phase of the software, and here software will be released to the customers for testing purpose, that is beta testing purpose. Either it can be open beta phase or closed beta release. Okay, open beta release or closed beta release. If it is open beta release, that means the release will happen to the complete public. If it is closed beta release, then the release will happen only to a set of or a group of a closed group of end users or customers. That is limited number of end users or customers only the release will happen. But there are the names. Okay, what is this name of the release that is happening as part of beta testing? Okay, in this RC phase or release candidate phase, there are several names. One of the name is gamma release. Okay, One of the name for the release of the software in the release candidate phase, RC phase of the software is the gamma release, guys. There are other names for gamma release, like different companies follow different naming conventions. Okay, some companies while releasing the software in the RC phase, they may call it as gamma release. Some companies may call it as RC release. Some companies may call it silver release. Some companies may call it as delta release. So hope guys you understood what exactly is gamma release in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 257. That is, what is delta release? Let me answer. So what is delta release? The release that happens in RC phase of the software, that is release candidate phase of the software, can be known as delta release. Okay, there are different names for the release that happens in the RC phase of the software. One of the names is delta release. Okay, so before that, the software goes through several phases. Okay, we have to understand that the software goes through several phases while getting developed, or during or while getting released into the market. The software has to go through several phases. There are five such kind of phases. That is pre-alpha phase, which is the first phase, then followed by alpha phase, then beta phase, and fourth phase is the release candidate phase, that is RC phase, and final phase is the stable phase. In the release candidate phase, if the software is released into the market, okay, that release can be named as delta release. One of the name is delta release. There are different names also, but for what purpose this release is happening, what exactly is this RC phase? Okay, let's understand in detail, guys. Okay, it's the fourth phase of the software. Here the software will be released into the market, not for selling or usage purpose of the customers. Okay, it will be released to the customers for testing purpose and for collecting the feedback from these end users and customers. Okay, they will give the software to the customers end users. Okay, whatever the software that has been developed so far till the RC phase, that software will be released as it is into the market. Okay, and will be given to the end users customers and ask them to use. So while the customers are using this particular software in different circumstances, different environments, different locations around the globe, okay, whatever the different machines, operating system, different configurations and all, okay, lot of feedback will be collected by the company, guys. Okay, it's not so possible for the company to do this level of testing. Okay, when they release the software to the end users or customers, okay, it's not the real release. Okay, they will mention that it is a beta release, and then they will release into the software, and customers will start using that as if they are really want to use the software for their real needs and all. So lot of feedback and lot of user needs and expectations can be found out with the help of this release. Okay, the company can find out, and this kind of testing which is done by the end user customers indirectly while using the software is called as beta testing. And the company may decide to release this particular software not to the entire public. Sometimes they will do a open beta release where the software will be released to the customers for testing purpose, that is beta testing purpose, for entire complete public, but not always. Sometimes the company may make a decision of closed beta release where only for a set of or closed group of or limited group of end users or customers only the software will be released, and these people only will be using the software as if they are using in the real time different environments and configurations, and the feedback will be collected from them. Okay, this release that is happening to the customers and where the customers are doing beta testing, okay, has several names. One of the name is delta release. The other names for this release, okay, apart from delta release, it is also called as RC release. Okay, depending on the company, guys. Some company may call it as RC release while releasing the software in the RC phase, or some company may call it silver release, some company may call it gamma release. Okay, and release the software. Some company may call it delta release and release the software into the market. So hope guys you understood what is delta release in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer software testing interview question 258. That is, what is stable phase of software? Let me answer. So what is stable phase of the software? Software has to go through several phases while during development or during all while getting released into the market, the software has to go through several phases. There are especially 5 phases of the software. They are pre-alpha phase, which is the first phase of the software, then alpha phase, second phase, beta, which is the third phase, release candidate, RC phase, which is the fourth phase, and the final phase of the software is the stable phase. As you can see here, stable phase is one of the phases of the software and is the final phase of the software. Fifth phase and final phase of the software. Here, for the first time, the software is getting released into the market for usage purpose, not for testing purpose. Okay, a finalized version of the software will be released into the market, guys. Okay, here till now a finalized version of the software is not released for usage purpose of the people or end users or real customers. Okay, the software has been released into the market in beta release candidate phase. It's not a real release. Okay, it is for beta testing purpose. It has been released for collecting the feedback from the end users and customers and knowing their end user needs and expectation. It was released in the previous phases, but for the first time in stable phase, okay, which is the last phase, a finalized version of the software, okay, which has gone through all the earlier phases of the software and which is stable now, which is meeting the user needs and expectations, which got corrected based on the feedback received in the beta and release candidate phase, which is kind of stable and is meeting the needs and expectations of the user, will be finally released into the market, okay, to the end users and real customers of the software for their actual usage purpose, not testing purpose. Okay, that is stable phase of the software. Okay, and we call this release as general availability release. Okay, we call this release of the software, which is the finalized version of the software, which can be used by the end users for their real usage, as general availability release. There is no going backward after the general availability release. This is the final version of the software released into the market for usage purpose of the end users or customers. Okay, as you already know, in the pre-alpha phase, developers will just start developing the software according to the given requirements and all, which is the first phase of software. Here formal testing has not started and there will not be any release here. And in the alpha phase, the formal testing will start. Okay, the second phase of the software, and the formal testing will start in the alpha phase. So not even the testers but also the developers will start testing in the alpha phase only. Developers will start testing using the unit testing followed by the integration testing. Then software testers will perform system testing on whole application. As an entire application, they will be performing system testing. And finally, user acceptance testing is also performed in alpha phase, but only one part of the user acceptance testing, that is alpha testing. Okay, there are alpha testing and beta testing part of the user acceptance, right? But only alpha testing part of the user acceptance testing will be performed by the client side business people, okay, who actually know the end user needs and expectations well. Okay, they interact with the customers or end users and they have the business knowledge. They will come up with a checklist and will make the developers to modify the software according to the user needs and expectations that these client side business people are believing. Okay, once the features are complete, once the software is developed according to the client given requirements and the checklist given by the client side business people, and if there is no other feature to be added, then alpha phase will be completed. Here also the software won't be released into the market. Okay, till now the software has not been released into the market either in pre-alpha phase or alpha phase. The software has not released into the market. And in beta phase, for the first time, this third phase of the software, and for the first time the software will be released into the market, but not for usage purpose of the customers or end users. Okay, for testing purpose, for getting this particular software tested in different circumstances, conditions, environments, locations. Okay, different configurations of the system, different operating system, whatever it is. Okay, that company cannot actually perform, right? To get that real feedback from the end users and customers. Beta, okay, in beta phase the software will be first time released into the market, but not for usage purpose, for testing purpose. Here beta testing will be performed and the company may decide to go with either open beta release or closed beta release, guys. As part of open beta release, the software will be released to the entire public for testing purpose, whereas in closed beta release, only for limited group of end users or customers it will be released and feedback will be collected. So once the feedback is incorporated and collected from the end users, okay, so still the confidence may not be so much good. Okay, so they another round of beta testing need to be performed, and that will be performed in the release candidate phase. Okay, here compared to the beta phase, the software looks more stable, guys. Okay, more stable, and most of the end user needs and expectations are actually covered as part of when RC phase starts. Okay, as part of the beta phase, once the software is incorporated with all the end users needs and expectations, so when confidence rises, then they will go with the release candidate phase, which is the fourth phase of the software. And here also, similar to beta phase, software will be released to the customers only for testing purpose, indirectly collecting the feedback from them in different situations and conditions and configurations and environments around the globe. Okay, so here also beta testing will be performed. Again, open beta or closed beta release decision will be taken by the company. If it is released into complete public, it is open beta release. If it is released to only limited group of end users or customers, it is called as closed beta release. Okay, and here there are different names for this release. The software that is released into the market for testing purpose or beta testing purpose, it has different names of the release. That is, it can be called as RC release or silver release, or it can be called as gamma release, or it can be called as delta release. And finally, once the feedback is collected, okay, once the feedback is collected in the RC phase, the software, this is the final feedback, you can say, guys, the software will be more, right, it becomes more stable, more it will meet the more needs and expectations of the user. When such kind of stage reaches, okay, the ultimate goal of the RC phase is completed and we'll move on to the stable phase. Okay, and once the final version of the software is ready, okay, this is the final phase of the software, fifth phase of the software. And here, guys, this is the final phase, final version of the software, which has all the client requirements developed, and also all the end user needs and expectations which are collected in the beta and RC phase were incorporated into the software, properly tested, developed, and everything, which is very stable and meeting the user and needs and expectations, and the confidence levels of the company is very, very high. In such cases, the finalized version of the software will be released into the market for the first time for usage purpose to the end users and customers. This time not for testing purpose. Okay, it is for, they will sell the software into the market. Okay, okay, the real software will be released into the market, and the name of the release will be general availability release. Okay, the way this finalized version release of the software is called as general availability release. So hope, guys, you understood what is the stable phase of the software now. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 259. That is, what is general availability release? Let me answer. So the general availability release is the release of the software which happens in the final phase of the software known as stable phase. Software goes through several phases. Okay, during the development or during or while getting released into the market, software has to go through several phases. There are five such kind of phases. They are pre-alpha phase, which is the first phase of the software. Then after pre-alpha, alpha, beta, release candidate phase, and stable phase, which is the last and final phase, fifth phase or final phase of the software. Okay, so in this phase of the software, the final version of the software, the finalized version, there is nothing left out. Okay, so we are releasing the software for the first time into the market for end users for usage purpose. The finalized version of the software, which has gone through the earlier phases and is stable now and meeting the user needs and expectations, and there is nothing much to change. And this is the last version of the software, and the company has decided to release into the market to the end user so that end users can purchase the software and use it for their day-to-day use. Okay, such a release is known as general availability release. Okay, till the previous phases, there you see in beta, in pre-alpha phase there is no release, in alpha phase there is no release, in beta phase there is a release, but it's not a real release. It is a release to the end users and customers with an intention of testing and collecting feedback from them. Okay, so for the end users to perform beta testing, here release will happen, but it's not the company has not decided to release the software into the market so that the end users can use it for their daily use and purchase it and kind of. Okay, that's not the real case in beta or release candidate phase. Okay, here 2 levels of beta testing will be performed, and finally a software will reach to the final level or final version of the software will be finally released into the market, which satisfies all the client requirements and also meets all the end users and requirements, end users and expectations which got gathered in beta and release candidate phase previous phases. And these end users can use there for their real time purpose. Okay, they can purchase and use it for their real time purpose, and this type of release is known as general availability release, is named as, okay, the release which happens in the stable phase, that is the final phase of the software, is called as general availability release. So hope guys you got the answer for what is general availability release in this session. So that's all for this session. In the next session I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 260. That is, what are the different phases of software? Let me answer. Software has several phases. While getting developed or during or while getting released into the market, software has to go through several phases. There are 5 such phases. They are pre-alpha phase, which is the first phase of the software. In this pre-alpha phase, which is the first phase of the software, developers will just start working on the software. Okay, they will start developing or coding the software. They'll write the code for developing or building the software with the help of the requirements or any other documents. Here, testing will not start. In the first phase of the software, the testing won't start, and also no software will be released into the market during this phase. In the pre-alpha phase, just the development will start, guys. That's it. Okay, even testing also will not start. The next phase, that is the second phase of the software, is the alpha phase, which is the second phase. Here, testing will start. Testing starts in the alpha phase of the software. So all levels of testing will start here. Okay. Here only development happened. Even developers have not performed unit and integration testing in this pre-alpha phase, but in alpha phase, all levels of software testing, that is unit level testing, integration testing, system testing, user acceptance testing, all testings will be performed. Developers will be first performing the unit level testing. Then after unit testing, developers will perform integration testing. Then software testers will test the entire software as a whole, and we generally call that as system testing. And finally, user acceptance testing, which is the last level of the testing, will also start, but it is partially done, guys. Under user acceptance testing, we have alpha testing and beta testing, but in this alpha phase, only one part of the user acceptance testing, that is alpha testing, will be performed. Beta testing won't be done. Okay, beta testing is not done in alpha phase. Only alpha testing is performed. So what is alpha testing under the user acceptance testing? As we already know, the client side business people, okay, the client side business people who has the business knowledge and who generally interact with the end users and customers and knows the end user needs and expectations well, will come up with a checklist, okay, checklist of their expectation of the software, and sit with the developers and see whether whatever the software they have developed is according to the checklist or not. If it is not, they will inform the developers to modify the software according to their expectations. Okay, so these business people may have more idea than the developers, right? So they know that what end user wants, expectations and needs, then know well. Accordingly, they will get this software modified, okay, as part of the alpha testing. Client side business people will move to the developer side, and this kind of alpha testing will be done by the client side business people. Testing team will also support during these changes. Here guys, all the features need to be completed as part of the alpha phase. That means according to the client specified requirements, according to the user needs and expectation checklist provided by the client side business people, all the features need to be completed. Okay, then only alpha testing will be completed. Here also software won't be released into the market, guys. Okay, in pre-alpha phase the software is not released into the market. In alpha phase also software is not released into the market. In pre-alpha phase just development started. In alpha phase different levels of testing started except beta testing. Now after the second phase, alpha testing, alpha phase of the software, beta phase of the software will start, which is the third phase of the software, where for the first time the software will be released into the market to the end users and customers, but the intention is different. It's not for selling the software in the market. Okay, it's for testing purpose. Okay, the company behind the software wants that is the real customers or end users to use this particular software. Okay, one and collect the appropriate feedback. Okay, proper feedback want to collect. Okay, so because the end users and customers will use the software at different location, different environment, different configurations, different situations and all, and because of this real time use, lot of feedback the company may get. That's the reason the software is released here. Software is not released for real purpose. The software is released for getting beta testing done by the end users and customers, and for collecting the feedback, realistic feedback from the end users and customers. So here the company who is releasing the software as part of beta testing to be done by the end users and customers may decide to go with open beta release or closed beta release in this phase. So open beta release means the software will be released for beta testing for the entire public, that is for the complete public around the globe. For closed beta means only for limited group of end users or customers only the software will be released and the feedback will be collected. Okay, that's what is beta phase. Once the feedback is collected and beta testing is done, and the realistic feedback is collected from the end users and customers in beta phase, then the next phase will start, that is release candidate phase. Okay, the next phase, release candidate phase, will start, guys. Okay, in the release candidate phase, okay, the release candidate phase is the fourth phase of the software. Here also again the software will be released. Okay, again the software will be released to the customers for testing purpose only. Okay, in beta phase also software is released for testing purpose. In release candidate phase also for the second time the software will be released to the customers for the same purpose, for the same beta testing purpose, to collect the realistic feedback. Okay, to get more confidence. So after incorporating this feedback into the software, again the software is released for the second time to see if the software is now meeting the end user needs and expectations or not. If not, if anything is missed, if any other needs and expectations of the users are missing, that feedback can be collected realistic way. Okay, here also the software, the company behind the software may release the software as open beta release or closed beta release. Open beta release means for the complete public. Closed beta release for only for the limited group of end users or customers it will be released. Okay, so there are several release names given for the software that is released in the RC phase, that is release candidate phase, that is the fourth phase. The different names that are provided, different companies follow different, call this release as different names. So one company may call that as RC release, some company may call that as silver release, some company may call it as gamma release while releasing the RC phase, some company may call it as delta release while releasing in the release candidate phase. And finally, once the feedback is collected in the release candidate phase and accommodated into the software will reach the final version. Okay, the final stage, that is stable phase. Okay, where the right, a complete feedback received in the beta and release candidate phase is actually accommodated according to user needs and expectations, and client requirements are also properly fulfilled. And this is the final phase of the software, guys. Here finalized version of the software, the last version of the software, which has gone through all the previous phases of the software, where the client requirements are met, the user needs and expectations are met, will be finally released into the market with the actual purpose. This time, for the first time, actual purpose, not for testing purpose. Actually, the software is getting released into the market. The end users or end customers who want to purchase the software will purchase and use it for their daily use in this final version of the software. And the name of the release is generally, okay, we generally call this release in the stable phase of the software as general availability release. So these are the different phases of the software. Okay, so that is pre-alpha phase, beta phase, release candidate phase, and stable phase. So hope guys you understood the different phases of the software. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 261. That is, explain software release life cycle. That is SRLC. Let me answer. So SRLC is software release life cycle. How the software will be released into the market. So to understand that, you need to understand the different phases of the software. Software goes through several phases while getting developed, while getting tested, while getting released into the market for different purposes. Software goes through several purposes. Okay, in which phases of the software will be released into the market is nothing but SRLC. Let me explain that phase by phase wise. So here we have 5 different phases in the software. That is pre-alpha phase, which is the first phase of the software. Then we have the alpha phase, second phase, beta phase, which is the third phase, release candidate, phase RC phase, which is the fourth phase. And finally, we have the stable phase, okay, which is the final phase. Okay. So pre-alpha phase is the first phase of the software. Here development just starts, and coming to the release, here no release will happen. Okay, no software will be released in the pre-alpha phase. Okay, here only development will start, even testing will not start. Okay, coming to the next phase of the software, that is alpha phase. After pre-alpha phase is completed, we move to the alpha phase of the software, okay, which is the second phase of the software. Here formal testing will start, and here also the software won't be released. Okay, the software won't be released into the market. Okay, there is no release in this pre-alpha phase and alpha phase. Here formal testing will be started, guys. That is the developers will be performing unit testing, integration testing. Till now in pre-alpha phase only development has started using the requirements or client provided documents, but no testing was started. In alpha phase of the software, the testing started. Even the developers have started the unit testing, integration testing. After the testers will perform system testing, then user acceptance testing will be performed by the client side business people who has end user knowledge, who has the knowledge on the end user needs and expectations. Here only one part of the user acceptance testing, that is alpha testing, will be performed at this level. Okay, in the alpha phase. Okay, so here also the software won't be released, guys. Okay, in pre-alpha phase software won't be released. In alpha phase also software won't be released. Okay, once the client specified requirements are incorporated into the software by the developers and tested by the testers, and also the client side business people shared checklist of user needs and expectations are incorporated into software, then only the alpha phase will be complete. Okay, fine. So after alpha phase, then beta phase will start, which is the third phase of the software. Here, the software will be released. Okay. In pre-alpha phase, software is not released. In alpha phase, the software is not released. But in beta phase, the software will be released, which is the third phase of the software. Software will be released into the market to the end users and end customers, but with a different purpose. Okay, not for usage purpose, for testing purpose, guys. Okay, the company behind the software want the customers to start using the software, okay, and collect the feedback from them. Okay, with an intention of collecting the feedback. This is not the final release of the software, guys. Okay, here the intention of releasing the software into the market is for beta testing purpose. Who will be performing beta testing? The end users and customers who belong to different locations, different regions, different right, different things, different categories, different environments, different configurations, all different circumstances. They will be using the software, and if the software is not working properly for any of the people, they will provide the feedback back to the company. Okay, for that purpose only the software is released. Okay, and here this testing is called as beta testing, which is not done in the alpha phase. Okay, alpha phase, up to alpha phase of user acceptance testing is done. Again, the second phase, second level of the user acceptance testing, after alpha testing in user acceptance testing, we generally perform beta testing. That will happen in the beta phase of the software. Here, the software will be released into the market as open beta release. Company may decide to release the software for beta testing as open beta release, or the company may decide to release the software into the market as a closed beta release. Okay, any of the type. Open beta release means the software will be released to the complete public around the globe. Whereas closed beta means only to the limited group of or closed group of end users or end customers it will be released, guys. Okay, that is beta. Fine. Then finally, we have the, so once beta phase is completed, once the feedback is collected, then we'll go to the RC phase. Whatever the feedback that is collected in the beta phase will be incorporated in the software. And again, the software will be made ready for releasing into the market with the same purpose. Okay, whatever the purpose the software got released into the market in the beta phase, with the same purpose again in RC phase, but the second time software will be released into the market to the end users and customers for testing purpose only. That is for beta testing purpose only, to collect the second level of feedback regarding the end users needs and expectations. Here also open beta release may happen or closed beta release may happen, deciding based on the company's decision. Okay, so open beta means complete public it will be released. Closed beta means only for the limited group of end users and customers it will be released. Okay, so there are different names for the release candidate, guys. Okay, so this release has different names. Okay, whatever the release that is happening in the RC phase has different names. Okay, The company may name this release as RC release. Okay, while releasing the software in the RC phase, the company may call it as a RC release. Depending on the company, company may call it as silver release, company may call it as gamma release, company may call it as delta release. Any of the names, with any of these names, the release will happen in the RC phase with an intention of collecting the feedback from the end users and end customers, where the end users, while using the software, will indirectly perform the beta testing. Okay. Once the RC phase is completed, a lot of feedback will be collected. That feedback will be incorporated into the software. Okay. In the last phase of the software, that is stable phase, where the main intention is to make the software stable. Okay, and to prepare a finalized version of the software. Okay, the final phase of the software, guys, a finalized version of the software need to be prepared and has to be released finally into the market for real purpose. The end users and customers have to purchase the software and use it for their real needs. Okay, this is a finalized version of the software, which has all the client specified requirements satisfied, and also the end user needs and expectations which are collected from the beta phase and RC phase are met. That kind of finalized version of the software, which looks more stable and more realistic, or more user based on created based on user needs and expectations, right? That finalized version of the software will be released into the market to the end users and customers for real use, for their real purpose use, or okay, real usage purpose. That is a stable release, and this release is actually called as general availability release. Okay, so this is what is SRLC, guys. Okay, software has different phases. In different phases, in some phases software will not be released, in some phases software will be released, but in beta and release candidate phase, it will be released with an intention of beta testing purpose. Whereas in the stable phase of the software, the actual release will happen for the end user usage. Okay, so where end users will purchase and general availability release will happen. Okay, this is what is SRLC, that is software release life cycle. So hope, guys, you understood what is software release life cycle in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 262. That is, in which phase of software the testing will stop? Let me answer. As you already know, there are several phases of the software. That is, 5 phases of the software. But in which phase of the software the testing will stop is a question. So the simple straightforward answer for this question is stable phase. So until the last phase of the software testers have to keep testing. Okay, testing will only stop in the last phase. So in pre-alpha phase, which is the first phase, only development will happen. Okay, developers will start developing the software, but nowhere testing will start. Okay, testing is not started in the pre-alpha phase. Formal testing, even developers will not even do unit testing, integration testing in pre-alpha phase. But in the next phase, that is alpha phase, the testing will start. Okay, formal testing will start, where developers will start with the unit testing, then integration testing, then software testers will do the system testing, where testing as a whole they will do, and user acceptance testing, where only one part, that is alpha testing, or part of the user acceptance testing will be done in the alpha phase. Okay, where client side business people who has the knowledge about what exactly the end user needs and expectations are, they will come up with a checklist and perform the alpha testing here. Okay, so testing starts in the alpha phase formally, and in beta phase, beta testing. Okay, the next phase of user acceptance testing, that is beta testing, will be done in the beta phase. And in the release candidate phase also, the beta testing, second level of beta testing will be performed in the RC phase. And finally, in stable phase also, before releasing the final version of the software, the testing has to be done to see whether we can release whether we can consider this software as a final version of the software or not. Testing has to be done, right? So testing will start from the alpha phase and will end or stop after the version of the software is finalized in the stable phase of the software. So hope, guys, you understood in which phase of software testing will stop. In stable phase, once the final version of the software is finalized, the testing will stop. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 263. That is, do we write test cases for smoke testing? Let me answer. First of all, what exactly is this smoke testing? So in smoke testing, once we receive the build from the developers for testing purpose, as software testers, we first focus on testing the major, important, and critical functionalities of the software. Okay, only the major, important, critical, showstopper functionalities of the software only will perform testing, and that too at a high level. Will not test all the test cases of major, important, critical functionalities. We'll test the high level test cases, only few high level important test cases, positive test cases of this major, important, critical functionalities of the software will perform in less time. Okay, will not take too much of time, 15 to 30 minutes max, based on the size and complexity of the application. Okay, that's what is smoke testing, right? So if any of this major, important, critical functionalities, okay, if any of the test cases in this high level test case of this major, important, critical functionalities of the software are failing, okay, then there is no point in moving to the detailed testing, okay, because the application is not working at a major, important, critical level. For example, if there is a defect in the login, you are unable to log in. What is the point of testing the application, right? Such kind of defects you'll find with the help of smoke testing. And if there are no defects found in this major, important, critical functionalities when tested at a high level and positive level in less time, if no defects are found, we'll accept the build from the developers. Okay, whatever the developers have provided the build for testing, that build we'll accept and proceed for the in detail testing, in depth testing. Okay, but what if there are some defects in this major, important, critical functionalities? As I mentioned, one example like you're unable to log in or something. In that case, we report that particular defect, okay, and we'll provide, okay, the details of the defect in the email to the development team, okay, saying, hi development team, okay, we have first performed smoke testing to see whether the major, important, critical functionalities of the software are working at a high level or not. And we come across one of the defect in one of the major functionality of the software, because of which the smoke testing has failed. Hence, we are rejecting the build and we'll be waiting for the next build, which may, and hoping for the next build to pass. Like that, we'll put an email to them and reject the build. Okay, that's what is smoke testing all about, right? That's why we do that. But the question here is, do we have to write test cases for smoke testing? Especially, you don't have to write any test cases for smoke testing, guys. Okay, especially for smoke testing, you don't have to write test cases. Maybe we may pick the test cases from the complete list of collection of test cases document that we have already created. Okay, we may choose the test cases from the existing test case document for the entire application, but we will not specially or specifically write test cases only for smoke testing. We don't write the test cases. Okay, in any of the project, we generally perform smoke testing like at a fly, but if required, we can also choose the test cases, but we don't have to write them separately for smoke testing. Okay, we pick the test cases from the existing complete list of test cases document, or we using our brain or something, we'll test at a high level. Okay, that's what is answer. So hope guys, you got the answer for the question. Do we write the test case for smoke testing? Especially we don't write. We pick them from the existing test cases, or we test them at the fly, on the fly. Okay, so that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 264. That is, what is build verification testing? Let me answer. Build verification testing is also known as smoke testing. Okay, the build verification testing is another name for smoke testing, guys. There is nothing much. Okay, so what exactly is smoke testing or build verification testing? In build verification testing or in smoke testing, we test the major, important, and critical functionalities of the software at a high level. Once the developer provides a build for testing, instead of directly going for in-depth or in-detail testing, first we perform smoke testing or build verification testing, where we test the major, important, and critical showstopper functionalities of the software, and that too at a high level. Only few test cases of this major, important, critical, few important test cases of the major, important, critical functionalities we are going to test. We are not going to test the entire test cases of these major, important, critical functionalities. At a high level, only few test cases of major, few important test cases of major important critical functionalities of the software we are going to test, and that too in less time. Okay, we should not take more time, guys. Just 15 to 30 minutes should be enough. Okay, based on the type of the application complexity, it should not take more than 30 minutes. Okay, so that is build verification testing or smoke testing. So why we have to perform build verification testing or smoke testing? So after performing smoke testing or build verification testing, we either accept the build from the developer or reject the build back to the developer. Okay, so if everything is fine, okay, after performing smoke testing, if the major important critical functionalities which are tested at a high level, okay, are working fine, okay, there are no defects, and it's a green signal for doing the in detail testing, right? Then we are going to accept the build. If not, if not, if you find a defect in this major important critical functionalities when they are tested at a high level, then we are going to reject the build. For example, there is a login functionality. In the login, you are unable to log in. That is important major critical functionality of the software, guys. And when you give valid credentials, you are unable to log in. So that means the defects are there at the major important critical functionalities which when tested at a high level only. So in that case, we are going to reject the build, guys. We are not going to proceed further for the in detail or in-depth testing. We simply reject the build back to the developers as part of build verification testing or smoke testing by writing an email saying that, hi developer, okay, so we perform smoke testing or build verification testing and observe that the smoke testing has failed because of the so and so defect. Okay, so please fix this defect and provide us the next build so that we can proceed further in detailed testing. Okay, like that we'll send an email to the developers. Okay, so this is what is build verification testing. So hope guys you understood what is build verification testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 265. That is, what is confidence testing? Let me answer. So confidence testing is nothing but smoke testing, guys. Okay, the other name for smoke testing is confidence testing. Both are same. Okay, so when a developer gives a build or software for you for testing, before going for the in-depth or in detail testing, we perform smoke testing or confidence testing. Okay, which is also called as smoke testing, is also known as confidence testing, where we test the major important critical functionalities of the software, and that too at a high level. Only few test cases of this major important critical functionalities of the software we are going to test, and that too in less time, guys. We should not be taking more than 15 to 30 minutes based on the type or complexity of the application. Okay, so just to get the confidence on the build, whether we can proceed for further testing or not, we perform confidence testing, which is otherwise known as smoke testing also, guys. So after performing confidence testing, that is smoke testing, we either accept the build or reject the build back to the developers. When we accept the build, when these major important critical functionalities which are tested at a high level, okay, that is with less number of test cases in major important critical functionalities are working fine, okay, then we can decide to proceed for the further in-depth or in detail testing. Then the software testing team will accept the build given by the developers. When we reject the build, if in this major important critical functionalities which are tested at a high level and positive way has any defect, in that case, it's not a good idea to proceed for the further in-depth testing. There we are going to reject the build. For example, the login functionality, okay, if you give valid credentials, you are not able to log in. That means a major important critical functionality of the software, which is tested at a very positive and high level, is not working fine. So for that particular login functionality, we have to report a defect and we have to send an email back to the developer saying rejecting the build. Okay, hi developer. Okay, we have performed this confidence testing, that is smoke testing or whatever the name you want to specify in that email. And while performing testing, we come across a defect in the major important critical functionality when we have tested at a high level and positive level. Okay, hence we are rejecting the build and we don't suggest for a in-depth testing on this particular build. We'll be waiting for the next build to pass the smoke testing or confidence testing. Like that, we have to send an email to the developers. Okay, that is what is confidence testing. So hope guys you understood what is confidence testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I am going to answer software testing interview question 266. That is, do we write test cases for sanity testing? Let me answer. First of all, what is sanity testing? Okay, before I answer whether we have to write test cases for sanity testing, let's understand what is sanity testing. Okay, when there are any code changes done by developer in the software, the impacted areas need to be tested in depth. Okay, that is what is sanity testing. As part of sanity testing, we test the impacted areas because of this code changes done by developer in depth, guys. Okay, that is sanity testing. Okay, so what may be the code changes that may be done by developer in the software, so that the other areas of the software or the areas where code changes happened got impacted. Okay, the reasons may be new feature incorporation. Okay, developer may try to incorporate a new feature into the software. Because of that, the areas of the application functionality may get impacted. And also sometimes we have to modify the existing ones. Okay, upgrade or modify, change. Okay, according to the client or customer requirements, we have to update the software. Okay, so in that case also code changes will happen and the areas of the software will get impacted. Sometimes we remove the unnecessary features in the software. Okay, so then also code changes will happen and areas will get impacted. And last thing is bug fixing. Okay, once the software testers report the defects or bugs, okay, then the developers, assigned developer, has to start fixing this defect. Okay, after fixing the defect or while fixing the defect, the code has to be changed, right? As part of fixing the defect, the code changes, and because of that code change, due to this bug fixing, the areas of the application functionality may get impacted. So if you know the areas of the application which got impacted due to this code changes because of any of these reasons, that areas of the application need to be tested in depth as part of sanity testing. The impacted areas of the application need to be tested in depth because of this code changes as part of what testing? Sanity testing. That's why we call sanity testing as a subset of regression testing. In regression testing, because of these code changes, you don't compromise any area of the application. Okay, complete functionality of the application. You think that there may be a side effect. Okay, because of code changes in one functionality of the application, the remaining all functionalities of the application you are suspecting of a side effects. Okay, for that you doing regression testing. But in sanity testing, what is the difference? Sanity testing only the impacted areas. If you know the impacted areas, you don't do the complete testing of the all the areas of the application. Rather, only you focus on testing the impacted areas in depth. Okay, whereas in regression testing, all areas of the functionality in depth. Okay, that's the difference, guys. Okay, sanity. That's why sanity testing is a subset of the regression testing. But the actual question here is, do we write test cases for sanity testing? The simple and straightforward answer for this question is no. We don't have to especially write test cases for sanity testing. Okay, when we write test cases in a normal document, okay, as part of normal test case creation document, we create all the test cases. For each and every functionality, we create the test cases in depth only, right? We make sure that while creating the test case document, for each and every functionality, we are creating the test cases in depth. So as part of sanity testing, you will pick that particular impacted areas from the test cases. And as already the test cases are created or written in depth, okay, you will only execute those test cases of the functionalities where the areas of the application got impacted. Okay, so that's the reason, guys. It's not specially required for you to specially create test cases for sanity testing because they are already present in the test case document that you have already written. So hope, guys, you got the answer for this question. So that's all for this session. In the next session, I'm going to answer another software testing interview question. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 267. That is, what is a host and what is a port number? Let me answer. So what is a host and port number? So let me explain in a detailed manner. Host is nothing but a computer. Let's say here, Let's say this is my laptop, guys. Okay, this is my laptop. I can call my laptop as a host. So how to identify my laptop? In order to identify my laptop, I have to use something known as IP address. With the help of IP address, okay, with the help of IP address, we can identify this laptop, or we generally call that as a host now. Host is nothing but a computer, guys. To identify the computer, we need an IP address. And in this host, there will be different softwares running, right? In a computer, there will be different softwares running, and these different softwares will be running on different port number. This software will be running on different port number. This software will be running on another port number. Like that, every software will run on a different port number. So if I have to identify or access a software which is running in this computer, then I have to use a combination of IP address colon port number. Okay, IP address colon port number. If I have to identify or access this computer, only IP address is required. But if I have to access a software which is running in this computer, then I have to, along with the IP address, I have to put a colon and provide a port number. Okay, so let me give a real world example so that this part will be more easy for you. So everyone know about a hotel, right? Okay, the hotel, what the hotel? Let's say hotel is a computer here. This computer or hotel contains several rooms. Okay, there will be several rooms. So all the people who check into the hotel will not stay in the same room, right? They will book a separate personal room. Okay, so like that, here guests are the software. Okay, and the hotel is a computer, which is nothing but the host. So here, like in this hotel, every room has a separate room number, right? Like that, here every software on this computer, that is host machine, will be running on a separate port number, like room number, port number. Okay, so in order to access this a particular room, what we have to do? First we have to go to the hotel, access the hotel, and in the hotel we have to go to that particular room. Similarly, if you want to access a software which is running on this computer, that is host, then first you have to use the IP address colon port number. For example, there is a software which is known as Jenkins. Okay, so if you install this Jenkins software in your machine, okay, it will get installed at the port number 8080. Okay, so let's say in this laptop, if I have installed Jenkins, then in the port number 8080, it will be installed. So if I have to access this Jenkins software in a browser, I have to type like this: HTTP colon / IP address of my machine. Okay, I have to give the either IP address of the machine, IP address of my machine. So how to find the IP address of the machine? Just say CMD and say IP config, and here IP4V, this one, guys, 192.168.0.101. Okay, here we have to give 192.168.0.101. Okay, this is the IP address for accessing my laptop. And where is this Jenkins software which is installed is running on the port number 8080. So to access, instead of accessing the computer, if you want to access the software which is running, Jenkins software which is running, I told you, right, Jenkins will be installed in the port number 8080. So I have to give colon 8080. Then if you press enter, if Jenkins is installed in your machine, you will get the page of the Jenkins, guys. Okay, since Jenkins is not installed in my machine at this moment and is not running now, right now in my machine right now, this will result in no page. But in real time, if you have installed Jenkins and if the Jenkins is running, and if you hit this URL with your own IP address and colon port number of the Jenkins, you'll get the Jenkins software available and accessible in this browser. Okay, so hope guys you understood what is a host and port number in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 268. That is, what is use case testing? Let me answer. So what is use case testing? Before understanding what is use case testing, we need to first understand what is meant by a use case. Okay, let's understand what are use cases first. After that, use case testing. So what are use case? What is a use case or what are use cases? Use cases describe the functional requirements of a software from the end user's perspective. Okay. So who will create these use cases? The business analyst is going to create these use cases, and these use cases describe the functional requirements of a software, okay, from the end user's perspective. Okay, so it's a better way of okay, it's a better way of representing the requirements of the software, guys. Simple words, if I have to say, you see, instead of writing in a textual format, if you describe a functional requirement of a software that the client is expecting the developer to develop or tester to test, if that particular requirement can be represented in the form of a use case instead of normal text format, okay, in the end user's perspective, that will be more better, right? So that's what is the purpose of the use case. And who is going to create the use case? Business analyst. Okay, so business analyst is going to create these use cases and incorporate them in part of the BRS document, business requirement specification document, or the business analyst may provide this use case document separately also sometimes. Okay, fine. So in a while, I'll show you the diagrammatical representation of a use case. After explaining some basics of the use case, I'll explain. For now, let's go with the theory. Okay. So with the help of the use cases, which are created by business analysts, the developers and testers can understand the application very well. Okay. So instead of giving a text and asking the developers and testers to understand the functional requirements of the software, if the business analyst creates the use cases and provides them to the developers and testers, then developers and testers can understand the actual requirements of the software very well. Okay, and that too from the end user's perspective. Okay, so now let's understand the basics of the use case, like how use cases will be created by the business analyst, what are the basic elements of the use case, how business analyst will create the use case, everything let's understand from these basics. Okay, so there are something known as use case diagrams that business analyst will create. As part of creating the use cases, the business analyst will create use case diagrams. So that use case diagrams generally include some elements like system, which is represented in the form of this kind of rectangle. And then there will be something known as in the use case diagram. The business analyst may use some actors. Okay. I'll give an example, guys. Just for now, just go through the elements one by one. Then use case. Use case is represented like this, oval symbol, and relationship between any of this system or actor or use case is represented in the form of the arrow. Okay, the form of arrow, useful for communicating ideas, requirements, or application flows with others. Okay, so what is the purpose of the use case diagrams? So instead of giving the text, if the business analyst give this kind of diagram represented with all these use case elements, okay, diagram elements, it will be very easy to communicate the ideas. Okay, so you can explain, you can transfer your whatever the business idea you have in your mind, requirement you have in your mind. Okay, whatever the application flow you have in your mind, you can communicate easily to others. That's what is the benefit. Example. Okay, this is very important, guys. Example, as you can see, there's an example for a banking app. Okay, this is a use case diagram. Let's say the business analyst has created this use case diagram with all the different type of use case elements like actors, use case, the relation, the system. The blue color box is the system here. Banking app is the system here. Okay, banking app is the system, and here we have some actors like customer. There are different type of customers like new customer and existing customer, and other actor is bank here. On the other side, we have the bank as another actor, and you see the customer use case, these orange color things are the use cases. Okay, the login use case. Okay, so to verify the password, login use case, to display the if you give wrong password, display login error. Okay, that is another use case. The customer can view balance in the bank, the customer can deposit the amount in the bank, the customer can make payment in the bank. Okay, different type of payments the customer can make using either credit card payment, the customer can make, or the customer can can make using the savings. Okay, from the savings account also can pay. Okay, you can make the payment like that. You see, this is more easy to understand than the text, right? Instead of giving the text, if the business analyst create this kind of use case diagram with all these different type of use case elements and give it to the developers and testers, the developers and testers can understand the application more well. Okay, developers can understand the requirements well and can develop the application well, and testers can understand the requirements and can write proper test cases and all those stuff. Okay, So here guys, how to create this use case diagram is out of topic. Okay, let's not worry about that. So the question actually we got in the interview is like we generally get in the interviews, what is use case testing? Okay, that's what is the question. But to understand what is use case testing, first we have to understand what is a use case. So till here I explained what exactly is the use case. With these 4 points I explained what exactly is the use case. Use case describes the functional requirements of a software in the end user's perspective, created by business analyst, and is very helpful for developers and testers in understanding the application well and basics like different elements of the use case and example of the use case. Okay, that I explained. Now, what exactly is use case testing is the question. So, what exactly is use case testing? So, before going to use case testing, you have to understand that there are different test design techniques. Okay, so there are different test design techniques that software testers follow to create the tests, to design the test, to derive the tests. For in order to perform testing later, okay, the tests have to be created. Okay, there are different techniques, guys. Okay, what are the different techniques we have? So used for deriving the test cases and optimizing the test data during the software testing is the test case design techniques need, guys. I already covered this as part of one of the previous video. Okay, I took a separate video, okay, interview question on the test design techniques. You can refer that. But for now, let's understand that there are 3 types of test design techniques. That is black box test design techniques, experience-based test design techniques, and structure-based test design techniques. Under black box test design technique, I already explained what is equivalence class partitioning, boundary value analysis, decision table, state transition testing, already covered, guys. And there is one more. These are already covered as part of the previous sessions, guys, but I didn't explain about the use case testing so far. So use case testing belong to the black box test design technique. Okay, we have other type of other category of test design techniques, but use case testing belong to the black box test design technique. Okay, here we have experience-based test design technique. Okay, and structure-based test design techniques are also there, but use case testing belongs to the black box test design technique category, where software testers can take the help of these use case diagrams given by the business analyst and derive the test cases. Okay, by looking at this diagram, we can create the test case. For example, if you see login, okay, verify password. So that means the scenario is login scenario, and the test case for the login scenario are, what if you try to log in with valid credentials? What if you try to log in with invalid credentials? What if you try to log in with invalid username and valid password? Okay, what if you try to log in with valid username and invalid password? What if you try to log in without providing the credentials? Okay, like that, for each and every use case you can derive a lot of test cases, right? So that type of test design technique which can help the software testers in deriving the test cases with the help of the use case diagrams given by the business analyst is known as use case testing, which is one of the black box test design black box test design technique, which falls under the test design techniques. Okay, one of the category of the test design techniques. This is what is use case testing, guys. So hope guys you understood what exactly is use case testing in this session. Okay, so it's a test design technique which falls into the black box category. Okay, so that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 269. That is, do we have to report the defects that are identified while you are performing smoke and sanity testing? Let me answer. So when you are performing smoke and sanity testing, if the defects pop up, do we have to report them into the defect tracking tools or test management tools? That is a question. The answer is yes. Okay. Whatever the testing you are doing, whatever the type of testing you are doing, if you are finding some defects in the software, the first thing the software testers have to do is they have to report. It may be smoke testing or sanity testing or any other type of testing. We have to report the defects that are identified during these testings into the defect tracking tools and test management tools. So hope guys you understood the answer for this question. So that's all for this session. In the next session, I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 270. That is, what is code coverage? Let me answer. So what is code coverage? Code coverage is nothing but measuring the amount of source code of software that is tested. Okay. So the developers will write a lot of code for developing the software, right? But how much of that code that is developed for the software is tested? If you are measuring that, that is nothing but code coverage. Okay, is a measurement to find out the amount of the source code that is written for the software that is actually tested. Okay, that is what is code coverage. It falls into the white box testing category, guys. Okay, it's a form of white box testing only. Okay, it's performed at the white box code level. Okay, so by developers, so which detects the areas of the software that are not executed by tests. Okay, what is the advantage of performing the code coverage? So we can know that how much amount of source code of the software is tested. That means that what portion of the software code is not tested also can be found out, right? We can detect the areas of the software code which are not tested it, which are not executed it because of the lack of the tests that are created at this white box testing level. Okay, some portion or area of the software code may not be tested. Okay, to detect that, we perform code coverage. So whenever there is a gap, okay, whenever there is a gap because of which the complete code of the software is not tested, okay, as part of this measurement, if it is found that the complete code of the software is not tested, then as part of white box testing, the developers have to create more tests. Okay, they have to create more tests to increase the test coverage. To increase the test coverage. That's why this code coverage falls under the structure based design techniques. Okay, so this particular code coverage, that's why it falls into the white box and it falls under the structure based design. Okay, there are different techniques, guys. You can call them as methods or techniques. Okay, as to perform this code coverage. Okay, there are different techniques or methods. They are nothing but statement coverage, branch coverage, path coverage, condition coverage, like that. Okay, there are different ways or methods or techniques under the structure based design to perform this code coverage. So I'll be explaining what is statement coverage, branch, path, and condition coverage in the upcoming sessions anyhow. But before that, let me take a small example, like how the code coverage happens. Okay, a small example, guys. Don't worry into which category of this coverage it falls into, the example falls into. All these things will be covered in the respective sessions for statement coverage, branch coverage, path coverage, and condition coverage. For now, understand it at a code coverage level. Let's say there is a program like this. Okay, let's say there is a program like this. It's written in Java, guys. There is a class. Inside the class, there is a main method from where the program execution will start, and there is a another method. From the main method, I'm calling this method. Okay, so I want to know the code coverage here. I want to know the code coverage. So how to identify the code coverage? For example, here only one test is there where you are passing 5 and value 5 and 4. If you are calling this particular method with the values 5, 4, 5 will go into A and 4 will go into B. So 5 plus 4 will become 9. The result is 9. If the result is greater than 0, here this statement will be printed. Positive result will be printed. This all the other statements will be skipped. Okay, these lines of code which I am highlighting will be skipped if the values that you are passing are 5, 4. Here the code coverage is how much? How many lines of code you are executing? In this method, there are 1, 2, 3, 4, 5, 6 lines. In that 6 lines, how many? Because of 5, 4, how many lines are getting executed? This line is getting executed because of 5 plus 4 calculation. 1 line, 2 line, 3 line. That's it. 3 lines are getting executed. What about the other 3 lines? 1, 2, 3 there. That is code coverage is only 50%. 50% of the code coverage. So now as part of white box testing, the developers have to increase the tests. They have to give different values. They have to pass different values. For example, here -8, 4 if they pass. Okay, -8 and 4 if they pass. What will happen? In this case, -8 will go into A, 4 will go into B. Let's say 5, 4 is completed. So these 3 lines were already executed. Now, as part of the second test, -8 and 4 are being passed in the code. -8 will go into A and 4 will go into B. So -8 plus 4 is -4. Result is not greater than 0. It will go into the else part. That is negative result will be printed. So this portion also is covered. So By increasing the number of tests, all the lines of the code are getting executed, right? So now the code coverage is 100%. Okay, 6 out of 6 lines got executed, 100% code coverage. So this is one example, guys, to make you guys understand what exactly is code coverage and how it is done at a white box testing level by developers. Okay, so it is nothing but the measuring the amount of the lines of the source code of the software that is being tested. Okay, how many lines of the software code are tested? If you are measuring, that is code coverage, where the number of tests need to be increased in order to increase the code coverage or test coverage as part of the code coverage. Okay, and it falls under the structure based test design, and there are different techniques to perform the code coverage. Different methods or ways or techniques. They are statement coverage, branch coverage, path coverage, and condition coverage, which will be explained in detail in the upcoming sessions. So that's all for this session. Hope you guys got the answer for this question. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 271. That is, what is statement coverage? Let me answer. So before understanding what is a statement coverage, you have to understand what is code coverage. Okay. So under code coverage, there are different techniques or methods or ways. One of the way is statement coverage. So what is code coverage? Here in code coverage, we are measuring the amount of the source code of the software that is tested. Okay, how much amount of the source code of the software is tested, that we are measuring as part of the code coverage. For that, there are different techniques, ways or methods known as statement coverage, branch coverage, path coverage, and condition coverage. In this session, I have to answer about one of the way or technique or method, that is statement coverage. Okay, that I am going to do so. Fine. So code coverage falls into the white box testing category, where okay, where the areas of the software code that are not executed by the test can be detected. Okay, when you are measuring how much amount of the source code or program of the software is tested as part of is covered or covered as tested as part of testing, that means you can find out how much gap is left, how much is not tested. Okay, we can detect the areas of the software code which are not tested. Okay, so to increase the coverage, more tests will be created by the developers. Okay, more tests will be created by the developers because this is white box testing generally done by developers. So more tests will be created for test coverage. Okay, to increase the amount of the lines of the source of the code of the program of the software that need to be tested, to increase that number of lines of the code that need to be executed. Okay, more tests have to be created. Hence, this code coverage falls into the structure based test design category. Okay, under this structure based test design category, there are different techniques or methods or ways, that is statement coverage, branch coverage, path coverage, and condition coverage. Now let me explain the main topic, that is what is statement coverage. Once you understand code coverage and its purpose, now you can understand what is statement coverage. There is a very simple formula for statement coverage, guys. That is, statement coverage is equal to number of executed statements, number of statements that got tested, divided by the total number of statements in the software. Okay, how many statements got executed or tested, divided by total number of statements into 100. So with example, I'll show you. Here guys, we have an example, okay, which is written in Java. If you don't know Java, don't worry guys, understand it at high level. There is a class, there is a main method from which execution will start, and there is another method. This particular method need to be tested for code coverage, let's say. Okay, let's say we are testing this method for code coverage. So assume that if you are passing two values, 4 and 5, if you are passing here, okay, this particular is a method calling statement which will call this method. So 4 will go into A and 5 will go into B. Okay, 4 will go into A, and so before that, how many lines of code are there in this program, in this particular method? 1, line 1, 2, 3, 4, 5, 6, total 6 lines are there. Okay, now if I am passing one test, as part of one test, if I am passing 4 and 5 as a developer, 4 will go into A, 5 will go into B, 4 plus 5 will become 9, result will become 9, 9 is greater than or equal to 0. This particular this statement is covered now. This statement is also covered. Since this result is true, we'll go inside the if block. Okay, this block, and system.out.println positive result will be executed. In the result, on the output, you will get positive result. What about this else block? This is not covered. So out of 1, 2, 3, 4, 5, 6, out of 6 lines, because of these inputs, only these lines got executed. 3 lines got executed. Okay, how many lines got executed or tested? 3 lines. But total number of lines are 6. So what is the statement coverage? How much is the statement coverage? Total number of lines executed is 3 divided by complete number of lines in the program into 100. If you enter that, you are getting 50%. 50% is the answer case. Okay, statement coverage in this case is a 50%. Now, the developers, as part of white box testing, has to increase the test, has to write more tests, so that test coverage should be increased. So what they thought is, okay, instead of 4 and 5 only, let's test with other numbers like -4, okay, -8 or something like this. Okay, some random numbers, -4, -8 like this. So -4 has been passed to A this time. This is the second test, guys. The first test, already these 3 lines got covered. 50% is already covered. In the second test, -4 is passed to A, -8 is passed to B. -4 plus -8 will become -12. Result is not greater than 0. So it will go into the else block. Now the remaining 3 lines also got executed. As part of the second test, this else block, negative result got printed, and this remaining lines which were not executed in the first test got executed in the second test. Now, how many lines are there? Total 6 lines. How many lines got executed because of these two tests, first test and second test? Total 6 lines. That means 6 divided by 6 into 100. This time 6 divided by 6 into 100. That is 100%. So statement coverage is 100%. This is how statement coverage will be done, guys. Okay. So hope guys you understood what exactly is statement coverage. Okay. So is one of the technique under the code coverage. Okay. It falls under the structure based design technique. Okay. Of the code coverage, where how many number of lines that got executed will be divided by total number of lines that are there in the software program multiplied by 100 to get the percentage of the statement coverage. So that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 272. That is, what is branch coverage? Let me answer. So what is branch coverage? Before understanding branch coverage, which is one of the technique of the code coverage, okay, let's first understand what is code coverage. Later I'll explain what is branch coverage. As part of code coverage, we measure the amount of the source code of the software that is tested. Okay, how much amount of the program program or code of the software is tested, is measured as part of the code coverage. Okay, it falls into the white box testing because it is related to code. Okay, and since we are measuring the amount of the source code or program code that of the software that is tested, we can easily find out the gaps case, like how much amount of the code is not tested is also we can find it out. Okay, if we measure how much is tested, we can simply find out how much of the code is not tested as part of execution or whatever it is. Okay, so when we find these gaps, by whenever we measure something, we find the gaps, right? So with the gaps, we have to fill the gaps. In order to fill the gaps, we have to increase our coverage, we have to increase our tests. Okay, we have to increase our tests so that more code will be tested. That's what is the aim. So how to do that? How to increase the amount of tests so that this code coverage will be increased? Okay, so for that there are some techniques I'll tell you. Okay, so this code coverage falls into the structure based test design, guys. Okay, it's a structure. There are techniques like, in order to increase the code coverage and all, there are some techniques like structure based test design techniques. Okay, in order to increase by creating more tests and increasing the code coverage, there are some techniques like structure based test design techniques. Okay, what are the structure based test design techniques? What are the different ways, methods and techniques that we can use for increasing the test and increasing the code coverage? They are nothing but statement coverage, which I covered in the previous session. Next one is branch coverage, which I'm going to cover now. The question is all about what is branch coverage, that I'm going to cover now. So path coverage, condition coverage. Okay, coming to the branch coverage, guys, there is a simple formula for branch coverage. So branch coverage is equal to number of executed branches divided by number of total number of branches. Okay, number of executed branches, whatever the number of branches that got executed by total number of branches. What are these branches? Into 100, guys. Okay, into 100. So I'll explain this formula with an example anyhow. So here we have a code, guys. Let me show you this code. This is not one. Let me close this. I'll open the proper one. Okay, as you can see this code, guys. Okay, so here we have some conditions here. This condition may either result in true or false. If there is true, it will go to one branch. If it is false, it will go to another branch. True branch, false branch. Similarly, there is one more condition in else if block. Here also, because of this condition may result in true or false. Okay, this condition may result in true or false. In case of true, it will go to one branch. In case of false, it will go to another branch. So total, since there are two conditions here, condition 1 and condition 2, each and every condition has two branches, that is true branch and false branch. Here also this condition also has true branch and false branch. So total how many branches? Total number of branches is equal to 4 divided by 4. But how many branches got executed? That depends on the number of tests. For example, one of the tests will take where we'll pass 4, 5 as a values. Okay. If you call this method with 4, 5, so how many branches will be covered? Let's see. Okay, 4 will go into A. When you call this method, this code is written in Java, guys. 4 will go into A, and 5 will go into B. Okay, and 5 plus 4 is equal to, that is 4 plus 5 is equal to 9. 9 is greater than 0. Okay, this is true. True branch is covered. Okay, there are two branches here. One branch is true branch, and other branch is false branch. In this true branch and false branch, which branch got covered when the output is 9? 4 plus 5 is 9. Result is 9. Is 9 is greater than 0. True branch got covered. Okay, this is covered now. Okay, one of the branch is covered. So this statement will be executed, and else if will not be executed, and else block will not be executed. That's it. That's it, guys. Only true branch of this condition has been executed. Only one. How much percentage? Now, if you only test with only these 4, 5 values, how much percentage, guys? Total number of branches is equal to 4. How many branches covered? Only one branch got covered, true branch of one condition. That is 1 by 4 into 100. That is 25%. Only 25% branch coverage is covered with this particular test. In order to increase the code coverage, what we have to do? In order to increase the code coverage, what we have to do? We have to change the values. We have to give another test here. Say -4, -5 this time. Okay, I'll give -4, -5 this time. What will happen? Let's see. -4 will go into A, -5 will go into B. -4 plus -5 is equal to -9. -9 greater than 0 is equal to false. This false branch is covered. This false branch is covered, guys. Okay, this false branch is covered. Since this false branch is covered, this will not go inside the if block. We'll go to else if condition, and here result less than 0. Here also two branches will be there. One branch will be true branch, and other branch will be false branch. False branch. So here -9, right? The result is -4 plus -5 is -9. -9 less than 0 is true. So true branch is covered here. True branch is covered here. Okay, so false branch in the first condition is covered with this -9, and true branch in the second condition is also covered. Okay, then this block will be executed, remaining everything will be skipped. So how many branches got covered now? True branch, false branch, and here true branch. 3 branches got covered. Total how many branches here? Total 4 branches. Out of that 3 branches, 3 divided by 4 into 100. Okay, what is the formula? Total branches are 4. 3 divided by 4 into 100. That is 75% branch coverage is done. Next. Next is what? This time I'll give both the values as 0. 0 and 0. Okay. 0 plus 0 is, result is 0. 0 greater than 0 is false. Already false branch is covered, so no problem. Here 0 less than 0 is also false. Okay, so now this false branch is covered now. Okay, with the, when you are passing zeros here, third test, this false branch is covered. Now this block will be skipped and else block will be executed. So all the branches got covered. Now all the 4 branches got covered with 3 tests. So 4 divided by 4 into 100 is 100%. Okay, now we got the branch coverage as 100%. So hope guys you understood what is branch coverage in this session. So that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 273. That is, what is path coverage? Let me answer. So, before understanding what exactly is path coverage, we should have the knowledge of code coverage. Okay, path coverage comes under code coverage. So, what is code coverage? So, in code coverage, we measure the amount of source code or program code of the software that is executed or tested. Okay, how much amount of source code or program code of the software is either executed or tested. Okay, we are going to measure as part of the code coverage. It falls into the white box testing because code is visible while you are measuring the amount of the source code. Okay, so by measuring the amount of the source code that is either executed or tested in the software, we can find out how much code is not executed. What is the gap? Okay, which areas of the software code are not executed or tested. So what we have to do to increase the code coverage, we have to increase our number of tests. Okay, so in order to increase the code coverage, in order to execute the more code, okay, and cover more code or execute more code or test more code, we have to increase the number of tests. Okay, increase the number of tests. For increasing the number of tests, there are different techniques. There are different techniques. Okay, so these techniques fall into structure-based test design techniques. So we know that there are different test design techniques, right? So in that, one of the categories structure based test design techniques. Okay, behavioral based. Second one is experience based, and that is black box test design techniques is the first one. Second one is experience based, and third one is structure based. Okay, which falls into the white box category altogether. These techniques are, so here we have to use these techniques to increase the code, increase the test so that more code will be executed and tested. Okay, so for that there are different ways, methods, and techniques. They are nothing but statement coverage, branch coverage, path coverage, and condition coverage. I already covered statement coverage in the previous session and also branch cover also in the previous session. Okay, in the previous sessions. So now coming to the path coverage. What is path coverage? So number of paths, guys. Okay, number of paths in the program that are covered. In simple words, how to do this path, how to use this technique of path coverage? We have to measure the number of paths in the program. Okay, how many paths in the program got executed? So that is nothing but the path coverage. I will explain this with an example so that it will be more easy for you. Here we have an example, guys. Okay, so for example here, let's say there is a method. I'm calling this method using this statement. This is Java code. So for example, if I give 5 and 4, okay, so 5 and 4, let's say, okay, 5 will go into A and 4 will go into B. So 5 plus 4 is equal to 9. Result will become 9. 9 greater than 50 is false. Okay, this code will be skipped. And 9 less than 50 is true. Less than 50 will be printed. So this is one path, okay, where if block is skipped and else if block got executed, right? If block got skipped and else if block get executed is one path. That is one path. Second path. Second path is what? What is the second path? Second path is I'll give numbers like 50, 40. 50 and 40. Let's say 50 will go into A, 40 will go into B. 50 plus 40 is equal to 90. 90 greater than 50. 90 is greater than 50 is true, right? So earlier the if block got skipped, but this time if block got executed, else if block got skipped. This is another path, end of the program. Okay. In one of the tests, when I gave 5 4, else if block got executed, that is one path where if block got skipped. That is one way, okay, of executing the program. When I give 50 40, if block got executed, else if block got skipped. That is the second way. Now what if I give 25 25 here? 25 and 25. So here, this will be another path where 25 plus 25 will become 50. 50 greater than 50 is false. This block will be skipped. 50 less than 50 is also false. This block also will be skipped. This is another path. Third path. So there are three paths that are coming in the program. Okay. By giving the number of tests here, different values for different tests, different paths are coming in the program. So total I identified three. So here path coverage is what? In this program, what is a path coverage? Path coverage is 3, guys. Okay. Path coverage is 3. The answer is 3. So hope guys you understood what exactly is path coverage in this session. So that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 274. That is, what is condition coverage? Let me answer. So what is condition coverage? So condition coverage comes under code coverage. So before understanding the condition coverage, we have to first understand the code coverage. So what is code coverage? Code coverage is nothing but measuring the amount of source code or program code that is written for building the software is tested or not. Okay. So how much amount of source code of the software is tested if you are measuring, that is called as code coverage. Sometimes you can call it as how much amount of source code of the software is executed or tested. Okay. Measuring the amount of source code of the software that is tested or executed is called as code coverage. And it falls under the white box because here code is visible while measuring the amount of the source code of the software that is tested or executed. Okay, code is visible, hence it falls into the white box testing category. And since we are measuring how much amount of source code of the software is tested or executed, indirectly we are also measuring how much gap is left, which areas of the software the source code is not tested or executed also can be found, right? So if there is a gap, or if you find some areas of the software where the code coverage has not been done, then the only solution there is to, we have to increase the number of tests. Okay. We have to increase the number of tests or inputs using which more amount of the code in the software will be covered, executed or tested. Okay. So to perform that, to create more tests, to increase the code coverage, there are different techniques. There are different techniques. We call them as structured based test design techniques. Okay. So under test design techniques, there are three types of test design techniques. One is black box test design techniques. Then we have experienced based test design techniques. And another one is structured based, that is a white box, right? Structure based test design techniques. Okay. This is the last category. Under the last category, we have different techniques which can be used for measuring the code coverage. What are those techniques? The techniques are statement coverage, branch coverage, path coverage, and condition coverage. Statement coverage, branch coverage, and path coverage I already covered in the previous sessions. Now, in this session, I am going to answer about the condition coverage. Okay, I'm going to answer about the condition coverage. So, what is condition coverage? Understand this condition coverage in the form of theoretical format first. As part of condition coverage, we are going to test all the condition expressions in the program. Okay, how many condition expressions are there in the program? For example for the condition expression is if in the circular bracket. If you know Java, if circular brackets, in between the circular bracket, whatever the condition you are putting, right, condition expression, that is called as condition expression. Okay, and in that condition expression, okay, in that condition expression, there can be only one possible outcome of condition or multiple possible outcomes can be there. In a single condition expression, you can have multiple outcomes possible. Okay, you can use AND operator or operator and divide the multiple condition outcomes like that. Okay, I'll give you an example so that you'll understand. So as part of condition coverage, we have to test the possible outcomes of each and every condition that is there in each and every condition expression of the program. Okay, this theoretical thing may look difficult to understand, but now I'm going to give an example. So with that, it will be very easy for you to understand, guys. Let's take this program, guys. So here I'm calling, this is a Java code, and here I'm calling this method with some values, right? With some values, I'm calling this method. Just understand condition coverage now. So here, there is only one condition expression. This is called as condition expression, guys. In this condition expression, how many possible condition outputs are there? One possible output, either it can output as true or false, and another possible output, that is C greater than D, it also can return in true or false. You can have any number of possible outcomes. For example, you can say B less than C, like this also you can write. Okay, now how many possible outcomes are there of the condition? Possible condition outcomes are there. One possible condition outcome, second possible condition outcome, third possible condition outcome. Total becomes a condition expression. This all becomes a condition expression. Okay, so here in a program, in this example, only one condition expression is there. In some other programs, there can be multiple condition expressions. In that multiple condition expressions, multiple possible condition outcomes can be there. Here, three possible condition outcomes are there. Okay, but this example has only two. I just for demonstration purpose, I increased one. Now, so here we have to test each and every condition outcome. Okay, how to test the condition outcomes in this condition expression? This condition can be true. This condition can also be true. That is one case. One case. Second one, this condition can be true. Second condition can be false. Second case. First condition can be false, but second condition can be true. Third case. This condition can be false, and last condition also can be false. Fourth case. So four tests we have to write. Okay, in order to complete the condition coverage, 100% condition coverage if you want, 100% condition coverage if you want. Okay, each and every combination you have to test. True, false, false, true, false, false. You have to check. Okay, in this example, this is called as condition coverage. Okay, there are other names for condition coverage. The other names for the condition coverage are we can also call the condition coverage as expression coverage or predicate coverage. Okay, there are other names for this condition coverage known as expression and predicate coverage. So hope guys you understood what is condition coverage in this session. So that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 275. That is, what is expression coverage? Let me answer. So, what is expression coverage? Before understanding what is expression coverage, we have to first understand what is code coverage. In code coverage, we measure the amount of source code or program code of the software that is tested or executed. Okay, so it falls into the white box testing category because here, while measuring the source code of the software that is tested or executed, we can see the code. So it falls into the white box testing category. And because of we measuring the amount of source code or program code of the software that is tested or executed, we can find the gap. Okay, we can find the gap in the software where the source code of the software is not tested or executed. That is the areas of the software code that are not executed or tested by the tests. Okay, that we can understand here which areas of the software code have not been covered as part of the code coverage, we can understand. So in order to increase the code coverage, we have to increase the number of tests. Okay, so the number of tests that are required for executing the gaps or areas of the software code that are not executed need to be increased. With that, the code coverage will be increased. Okay, so to perform this, to perform more tests on the software code to increase the code coverage, there are different techniques. They are called as structured based test design techniques. So at a high level, test design techniques are categorized into black box test design techniques, then experience based test design techniques, and the last one is the structured based test design techniques. So there are different techniques under this structure based test design techniques, ways or methods you can also call. They are statement coverage is one structured based test design technique. Then we have the branch coverage, another test design technique. Then we have the path coverage and condition coverage, which is another structured based test design technique. So, under condition coverage guys, okay, condition coverage has different names, but this question is all about expression coverage. But why I'm referring to condition coverage? Because the other name for the condition coverage is nothing but the expression coverage only. Okay, the other name for condition coverage is, you can also call the condition coverage as expression coverage. If someone is asking you what is condition coverage, or if someone is asking you in the interviews what is expression coverage, the answer is same guys. Okay, so either condition coverage or expression coverage, both are same. So what do we do in the condition coverage? We test all the condition expressions in the program. Okay, in a program, if there are one or more condition expressions, okay, we have to test all the possible outcomes of the conditions in the condition expressions. So theoretically, you may not understand this statement, but let me explain this practically, guys. Okay, here we have a sample Java code. Here I am calling the method. This is the Java code, guys, and here I'm calling this method. So when this particular method is called, what's happening is, you see, in this particular method, there is only one condition expression. Only this part is the condition expression. This is only the condition expression. A greater than B and C greater than D, which is inside the circular brackets, is the condition expression. But how many condition outcomes are there? There are two condition outcomes. This condition may result in a single condition expression. There are multiple condition outputs or outcomes. So this will result in true or false, or this may result in true or false. Okay. So how to perform condition coverage or expression coverage? We have to execute. Okay. We have to test all the possible outcome conditions in the condition expressions. Here we have only one condition expression. In that, whatever the possible condition outcomes are there, each and every possible outcome we have to test. So how many combinations will come? True. Okay, this may result in true. This may also result in true. True is one combination. Then true and false. Then false and true. And finally false and false. Both are false. So how many tests are required here? 4 tests are required. Okay, in order to test this condition expression having the multiple condition outcomes. Okay, so we have to give 4. What if there are one more possible condition outcome? For example, here there is one more thing like either or and whatever you can put it here, guys. Okay, so let's say there is something like B less than C. B less than C. Okay, B less than C. So there are 3 possible condition outcomes. Now if I have to test this, I have to test with a different combination. True, 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 false, true, false, true, false, true, true, like that, guys. Okay, like that we have to increase the number of condition. Mostly 8 will come, 8 possible tests will come here to complete the condition coverage. Okay, to complete the condition coverage in this example, 8 outcomes will come. Okay, if there are only 2 condition outcomes in this condition expression, 4 possible tests will come. But it is not compulsory that there will be only one condition expression. There can be multiple condition expressions in the program. This is only one condition expression, right? This is only one condition expression, but in a program there can be multiple condition expressions having multiple condition outcomes. So testing all the condition outcomes with possibilities of true and false combinations is nothing but condition coverage or expression coverage. Both are same. So hope guys you understood what is expression coverage. Expression coverage in this particular example is 4 tests. 4 tests. That is if you test all the 4 tests, then 100% condition coverage or expression coverage you can say. If you only test a true and false, true and true combination, there are 4 combinations, right? True, 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 false, false, true, false, false. If you only test true, true, then what is the condition coverage? Only 1 by 4, that is 25%. If you test true, 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 false, only 2 possible conditions. Okay, that means 50% coverage. Like that expression coverage is 50% in that case. But if you test true, 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 false, false, true, false, false, then all the 4 by 4 conditions are covered. Condition outcomes are condition outcome possibilities are covered. Then it will be 100% expression coverage or condition coverage. Okay, so this is what is expression coverage, guys. So that's all for this session. In the next session I am going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session I am going to answer software testing interview question 276. That is, what is predicate coverage? Let me answer. So what is predicate coverage? Before understanding what is predicate coverage, we have to first understand what is code coverage, because predicate coverage comes under code coverage. So what is code coverage first? In code coverage, we measure the amount of the source code of the software that is tested or executed. Okay, so we measure the amount of the source code or program code of the software that is tested or executed. Okay, it falls into the white box testing category, because while measuring the amount of the source code of the software, we can see the code. So it falls into the white box testing category. And by measuring the how much amount of the source code of the software is either tested or executed, we can find out the gaps or the areas of the software code that are not executed or tested. Okay, that are not executed or executed by the tests. Okay, so that is the advantage of the code coverage. So how to increase the amount of the source code that need to be executed? For that, we have to increase the more number of tests. If you create more tests, more the amount of the source code of the software will be executed. Okay, so for that there are different techniques. In order to test, in order to increase the number of the tests for the code coverage, to increase the code coverage, there are number of different test design techniques. They are called as structured based test design techniques. Okay. So there are different test design techniques categories. One is black box test design technique. Second one is experienced based test design techniques, and third one is the structured based test design technique, which is all about white box category of test design techniques, which fall into the measuring of the code coverage and all. Okay, what are those techniques or ways or methods for creating the test to increase the code coverage? The different methods we have are different structure based test design techniques we have are statement coverage test design technique, branch coverage test design technique, path coverage test design technique, and condition coverage test design technique. But the question is all about predicate coverage. But here we only have statement, branch, path, condition. So what about the predicate coverage? Simple guys, condition coverage has other names. What are they? Expression coverage and predicate coverage. Predicate coverage is nothing but the condition coverage only. Okay. So how do we increase the tests, or how do we create the test for condition coverage or predicate coverage? For this, we test all the condition expressions in the program. Okay. We test all the conditions expressions in the software program for all possible outcomes of the condition in the condition expressions. To understand this particular statement, let me take an example. Okay, so this is a sample Java code, guys. Okay, here I'm calling this method. This method is being called. If you see inside this method, guys, there is only one condition expression. But a program can have more than one condition expressions. But here in this example, only one condition expression is there. But how many possible condition outcomes are there? Two possible condition outcomes are there. So we can test something like this: true, 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 false, false, true, false, false. Four possible outcomes, right? So four possible tests are there. Okay. Here two condition outputs have four possible tests. We can create four possible tests. For example, if you are testing this code for true and true only, then 25% of the predicate coverage is done or condition coverage is done. But if you are testing for true, true, and true, false, for the first possible outcome true and second possible outcome true, and first possible outcome true and second possible outcome false, like the two tests, how much percentage of the coverage of predicate coverage? 50%. Total how many are possible? Four are possible: true, 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 false, false, true, false, false. Four possible conditions are there. Not only that, guys, a program can contain more than one condition expressions, and that condition expressions can contain more than one or more than more condition outcomes also. For example, here I can have b less than c also. Here three possible outcomes. In a single expression, we have three possible condition outcomes. Okay, that means true, 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 false, true, false, true, false, true, true. Okay, like that, and so on. Okay, so most probably 8 tests will come. Okay, for the test coverage. So here in this example, only two are there. So only four. Out of four, how many condition outcomes you have tested? Possible outcome combinations you have tested is nothing but predicate coverage or condition coverage. So hope guys you understood what is predicate coverage in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 277. That is, what is decision coverage? Let me answer. So before understanding what exactly is decision coverage, you have to first understand what is code coverage. Code coverage is nothing but measuring the amount of the source code of the software that is tested or executed. Okay, in this code coverage, we are measuring the amount of the program code of the software that is executed or tested. Okay, it is a form of white box testing because code is visible here. So indirectly, by measuring the amount of the source code or program code of the software which is tested or executed, we are finding the gaps or areas of the software code that are not executed by the tests, right? Indirectly, when you are measuring how much amount is completed, automatically we'll find out the amount that is not completed also, right? The areas of the software code that are not executed by the tests also we can find it out indirectly with the help of this code coverage. So when there are some gaps or areas of the software code that are not tested or executed by the tests, then we have to increase our tests. Okay, we have to follow some test design techniques and increase our tests so that code coverage will increase. So For that, we have different tests which fall under structured based test design techniques. There are different type of test design techniques like black box test design techniques. Then we have experienced based test design techniques. Then we have structured based test design techniques, which is a third category. So all the structured based test design techniques are for creating the tests for increasing the coverage or for code coverage. Okay, for covering the software code that is test by tested or executed. All these techniques are being used. Okay, there are different ways, methods, or techniques for increasing the number of tests for increasing the code coverage. What are they? They are statement coverage, branch coverage, path coverage, condition coverage. All these type of coverages are already covered in the previous sessions. Now coming to the another coverage that people talk about in code coverage is decision coverage. Okay, decision coverage structure based design technique. What is this technique actually? So as part of this technique, this is a formula case. Decision coverage is equal to number of decision outcomes exercised, that is executed or tested, by number of decision outcomes. Okay, total number of decision outcomes into 100. This formula I will explain with a practical demonstration with the code. Okay, assume that this is a Java code. Okay, this is a Java code, guys, and here we are calling the method. When we are calling the method, we are passing two values, right? So 1 and 2. So 1 will go into A, 2 will go into B. That's fine. So there is a condition here, condition expression you can say also. So there is an outcome. So this condition may result in true. This condition may result in false. So how many total number of decision outcomes are there? Only two, true or false. Okay, divided by 2. In this example, it is divided by 2. Okay, for example, if you are on, if your test is only having the arguments passing by if your testing by passing the arguments are 1 and 2, 1 will go into A, 2 will go into B, 1 greater than 2. True or false? 1 greater than 2. True or false? False. Okay, only false outcome of this decision is covered. So only one outcome is covered. So when it is false, this particular else block will be executed, right? So here the formula will be 1 divided by 2 into 100. Total decision outcomes are 2, that is true and false. But only for false case, we have exercised the code. So 1 divided by 2 into 100, 50% only. Now again, if you pass some other values like 2, 1, for example, 2, 1. Here, what will happen? 2 will go into A, 1 will go into B. 2 greater than 1 is true. So another possible outcome of this decision is also covered. Two outcomes are covered. So 2 divided by 2 into 100, that is nothing but 1 into 100, that is 100% decision coverage. So this is what is called as decision coverage, guys. This is how we measure. Okay, this is how we actually calculate the decision coverage, which actually increases the test to increase the code coverage. Okay, so that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 278. That is, what is cyclomatic complexity? Let me answer. So what is cyclomatic complexity? It's a metric, guys. Okay, metric means using this metric, any metric, right? We can measure, for example, kg are a metric, right? We can measure the weight like that. Okay, kilometers is a metric using which we can measure the distance. Similarly, cyclomatic complexity is also a metric, but what it is going to measure? It's going to measure the complexity of a program. How complex the program is, that we are going to measure. Okay, how we are going to measure? We are going to measure by counting the number of linearly independent paths in the program. Okay, so what is this linearly independent paths in the program? Don't worry about that. I have a practical program with me, and using that program, I'll show you practically by the end of this video or session. I'll show you practically how to calculate the cyclomatic complexity of a program. Okay, so at that time you'll understand what are independent paths. Okay, fine. Finally, here guys, using cyclomatic complexity metric. Okay, what we generally do is we'll take a program and convert that program into a control flow graph. Okay, we'll create a graph for that. Okay, in order to calculate this metric, in order to calculate this metric, or in order to measure the cyclomatic complexity, we have to design a or draw a control flow graph for the program. Okay, for which you want to calculate the complexity or measure the complexity, okay, of the program. Okay, for that program we have to draw the control flow graph. How to draw, I'm going to show you. Okay, and this uh, while calculating, guys, okay, while calculating, after drawing the graph, right, we have to go with this formula, guys. Okay, after drawing this control flow graph, we have to follow this formula, that is equal to measurement metric is equal to E minus N. E means edges, N means nodes, P means program. Okay, how many programs are there? That is P. Okay, how many nodes are there? That is N. How many edges are there? That is N. Okay, E, that how many edges are there? That is E. M is measurement or metric, whatever you can call. Okay, this is a formula, guys. So how to use this formula and how to calculate the cyclomatic complexity of an example program, I am going to show you right now. Here is a program. Okay, here is a program written in Java, guys. So from here to here, you can consider that as a program. If I have to draw like this, okay, if I have to draw a whatever the graph I told you, right, control flow graph, if I have to draw for this program, I'll consider this highlighted portion. So here I'll draw like this. Okay, I'll use paint. First I'll draw like this. First I'll draw this one and say start. Okay, this is starting point. Okay, this is the starting point. After starting point, here I'll write like this. I'll draw like this, and here there is a line. Okay, there is a line. So for that I'll write a box. Okay, it's not a condition. So I'll draw a box like this, and in that box I'll mention a is equal to 20, comma, what is the next one? B is equal to 10, B is equal to 10, comma, the third one is C is equal to 8. Okay, C is equal to 8. Okay, the box is big, that's fine, guys. Okay, let the box be big. This much box is not required, or we can do one thing. We can cut off like this. Okay, cut off like this, and we can reduce the size. Okay, we can reduce the size, no need to worry. Yeah, look wise it will not be looking good, right? So like this, fine. Okay, if you want to move this aside, you can also do that. Yeah, fine. Like this we have to draw. So after that there is a condition, right? To go to that condition, again we need a line here. Okay, we need a line to go to that condition. I'll put a arrow here, put a arrow, and if a is equal to 10, if a is equal to, sorry, if a is equal to, we are checking a condition here, guys. Okay, we are checking a condition, that is a condition will be checked like this. Condition is checked like this. If you want to reduce the size, you can reduce like this. A is equal to 20. Okay, a equal to 20, equal to 20. Okay, that is a condition, and the condition may either result in true or may result in false. Okay, if it is true, what should happen? So it will, if it is true, it will go in this direction. Let's assume, for example, if it is true, the condition is true, then it will go in this direction. That is, it will go into another one. Another condition will be checked here. Okay, if this condition is true, means another condition will be checked. So where the condition will be leading to, where this route will be leading to, this route will be leading to another condition. In case of true, this another condition is there here. Okay, so again one more thing we have to take like this, a condition box we have to take. Okay, so one more condition box we have to take, and reduce the size like this. And here B is less than C is the condition. Okay, B is, what is that, guys? B is greater than C, sorry, B is greater than C. Okay, another condition is coming here. So but what if the condition is false? We'll straightforward go to the last point. Okay, so if the condition is false, we'll straightforward go to the last point. Let's do that later. This also condition may either result in true or false, guys. Okay, this condition also may result in true or false. This may result in true, this may result in false, let's assume. Okay, so I'll write down here. Here also there is a false case which I have not drawn. So I'll put F for now. I'll complete this diagram later. Okay, so what if it is true? What if it is false? Okay, if it is true again, if it is true again, A is equal to B. Okay, if it is true, then here we have to write a block like this. Okay, that is A is equal to B. A equal to B. Okay, if it is true, then A equal to B. But if it is false, then A is equal to C. If it is false, then this block will come, that is A equal to C. Fine, these two cases. Okay, A is equal to B or A is equal to C. Now, whatever the case may be, the program is coming to an end, right? Either it go to if block or else block, the program is coming to the end and it will simply print A. Okay. Here it will draw like this and draw like this, draw like this, and finally, what is there? Print A. Okay, this is nothing but finally here, last statement, that is we are printing A. Here I'll simply write print A. Okay, print A like this. Okay, I'll just reduce the size so that you can see this complete diagram in full. Now I'll take this part. If not, if false also, if this condition is false also, we have to print A, right? So that means it will join here. Okay, will join here, guys. Here and then it will join here like this. Okay, this is what is the diagram we have to draw. So now let's see the formula. Okay, for calculating the cyclomatic complexity, this is the formula. M is equal to E minus N plus 2 into P. So let's write that formula here itself. M is equal to what is the formula? E minus N plus 2 multiplied by P. So how to calculate this formula? Okay, so I'll tell you. I'll just increase the size a bit so that it is not too small, not too large. Okay, this is fine. So M is equal to how many edges are there here? How many edges? So edges, E for edges, right? If you can see here, E stands for edges. Edges means the connecting points. Okay, this arrow is one connecting point, 1, 2. Then here 3. This is 4. This is 5. This is 6. This is 7. This is 8. Total 8, guys. Okay, 8. 8 edge points are there. And how many nodes are there? How to calculate the nodes? So there is one more thing, guys. I forgot in the diagram. Sorry. So here we have to say end. Okay, this node I was missing. Sorry for that. I forgot end. Okay, starting point, ending point. So how many nodes are there? 1 starting node. Then 2, 3, 4, 5, 6, 7, 8. Total 8. So here again 8 will come. So 8 minus 8 plus 2 multiplied by how many programs these are? This is only one program. So 1. Okay. So what is the formula here? M is equal to E minus N plus 2 into P. 8 minus 8 is equal to 0. 2 into 1 is equal to 2. So what is the cyclomatic complexity of this program? The cyclomatic complexity of this program is, the answer is 2, guys. Okay. The answer is 2. This is how we have to calculate the cyclomatic complexity of a program. Okay. So here we are drawing, okay, converting the program into a control flow diagram and calculating the number of edges, nodes, and okay. So independent paths are nothing but edges, guys, here, and nodes, and program will be anyhow one. If there are multiple programs connected, then you can keep the number high. But here the formula finally is M is equal to E minus N plus 2 into P. Okay, and we got the answer for this diagram. Okay, for this particular program, when we have drawn the diagram and calculated the cyclomatic complexity, we got the answer as the complexity level of this particular code is 2, guys. Okay, the complexity level of this particular code is 2. Okay, so hope, guys, you understood what is cyclomatic complexity with an example and practical demonstration in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 279. That is, what is the approach to be followed by the testing team when the build is arrived late and is not tested completely in the sprint? Okay, so what the testing team has to do when the build they have to test has arrived late or given late for them in the sprint, and because of that reason, if they are unable to complete testing in that current sprint, then what the testing team has to do? Okay, if you face this kind of situation, what the testing team has to do? So let me answer it, guys. Okay, so first of all, this is not the problem of the testing team, because the build has to be provided for testing or to the testing team on time. If it is not provided to the testing team on time due to many reasons, okay, it may be of because of many reasons, because developers may delay it, or there may be some confusions in the requirements, and because of that it got delayed, whatever the reason may be. Okay, but still, if the build has come for testing, if the stories that are assigned in that particular sprint have to come for testing very late in the sprint, and the testing team doesn't have much time, then what the testing team has to do is a question. So simple thing that will happen here is, since there is not enough time, okay, since there is not enough time to complete the testing, the stories will spill into the next sprint. Okay, the story will spill into the, whatever the stories are there, they will get spill into the next sprint. Okay, because they cannot be completed in the current sprint. That is the first thing. Okay, and when the build is getting delayed due to any reasons, because developers may be slow, or okay, requirements are confusing, or whatever it may be, the testers can sense it, right? They can understand that the build that has to come by this time has not come for our testing, so they can raise a risk flag in the daily stand up meeting where scrum master will be there, and they can raise the red flag there, saying that the build is not given for testing. If the build doesn't come by this time, then we will not be able to complete testing in this current sprint. Okay, and we need to spill it into the next sprint. Okay, like that we have to make the things straight in the daily stand up meeting and discuss with the scrum meeting, and go with the other meetings, so where actions can be taken place, and a contingency plan should be ready, or should be made ready in place in case of delay in the development. Okay, if in case the build is getting delayed because of there is a delay in the development, then a contingency plan need to be created by the testing team and should be made ready, and need to be discussed in the daily stand up meeting by raising the red flag, saying that we cannot complete the testing in this sprint. Okay, so we don't have enough time to complete the testing. So testing team with the above contingency plan should state that stories need to be spilled. Okay, stories need to be spilled, spelling mistake is there, spilled into the next sprint, and the build cannot go to production without proper testing in the current sprint. Okay, we need to spill the stories into the next sprint, then only we'll get the time for testing. Like that we have to make things straight. Okay, instead of taking the burden of testing in less time, we have to make the things straight, and make sure that you test the stories assigned to the sprint properly without okay, compromising with the time. Okay, so hope guys you got the answer for this question. In the next session I'm going to answer another software testing interview question for you. Till then, see you, bye bye. Hello all, welcome to this session. In this session I'm going to answer software testing interview question 280, that is, what is Kanban? Let me answer. So what is Kanban? Kanban is one of the agile methodologies. First of all, there are different SDLC models like waterfall model, spiral model, Big Bang model, V model, agile model, RAD model, and so on. Agile is one of the SDLC models. Under agile SDLC model, there are different methodologies, or we can call them as frameworks. Agile methodologies are agile frameworks we have. Kanban is one of them. So what are the different agile methodologies we generally have? We generally have the agile methodologies as Scrum, Kanban. You see, Kanban is one of the agile methodology or framework. Lean, extreme programming, Crystal, DSDM, and others. Okay. So Kanban is, you say Scrum is the top number one in the market, guys. Okay. Most of the projects in the market are using Scrum methodology of agile, but it doesn't mean that Kanban is not being used. Kanban is also famous in the market. Okay. So second famous I can say is Kanban. Okay. So some projects are using even Kanban. Okay. So Scrum and Kanban are leading in the market as part of agile methodologies or frameworks. So if you already know Scrum, you may have heard about a term known as sprints. Okay. In the previous sessions, in the one of the previous sessions interview questions, I already covered what is Scrum, guys. Okay. If you are following this interview questions in a sequence manner, okay, by this time you already know what is Scrum and what are sprints and all those stuff. I don't have to explain. Okay. In Scrum, the work will happen in the form of sprints, that is iterations. Okay. that is time bound iterations. Every 2 weeks, some work will be assigned. By the end of the 2 weeks, the work need to be completed. Again, next sprint will start in Scrum, guys. So I'm talking about Scrum methodology. So work will happen in the form of iterations like this. Okay, I'll show you. In Scrum, the work will happen in the form of iterations. Iteration 1, 2 weeks. In the 2 weeks, whatever the amount of work requirements are given, that requirements need to be developed, tested, and done whatever delivered by the end of the sprint. Okay, so the functionality should be ready. After this sprint is completed, first sprint of 2 weeks, let's say 2 weeks is completed, then second sprint will start, second iteration will start. Some other set of requirements or stories based on the priorities and urgencies will be assigned, and they need to be completed by the end of the sprint. Third iteration, fourth iteration, fifth iteration, sixth iteration, and so on, guys. This is how the work happens in Scrum. Okay, these are all sprints. These iterations which are time bound, like 2 weeks time bound, are nothing but sprints. But in Kanban, we don't have any sprints. Now, there is no time bound, guys. We are not going to fix the time. Okay, in Kanban, there is no fixing of the time. Okay, the work will not happen in iterations. It is a continuous work. Work will be done in a continuous process. Okay, this much amount of work is there, take it and do it. That's it. Okay, you don't have to complete in 2 weeks or 3 weeks or 1 week or 4 weeks like that we do in Scrum. But in Kanban, it's just a continuous process, guys. Okay, work started, work need to be completed over a period of time. Okay, work need to be completed over a period. It is a continuous process. Okay, so here work in progress limit will be there. So I'll explain, guys, how the work happens in Kanban. Okay, I'm talking about Kanban here. Just see here, Kanban. In Kanban, how the work happens is, you see, let's say there is a board here. Okay, let's break this board into 3 parts. I don't want to make this concept complex. You can go for complex videos also on Kanban, but whatever I'm explaining will be enough for you guys to understand Kanban. If you already know Scrum, Kanban is very easy to understand. Okay, here develop or build. Okay, develop, then test and done state. Okay, done state. Like this, 3 states are there, and here all the requirements are there. Okay, all the requirements in the form of stories or whatever you call, right, will be there. All the requirements, okay, will be there. So out of all these requirements or stories, whatever you call, okay, you have to assign them. Okay, so here, but here the work is a continuous process. There is no time bound. There is no 2 weeks or 3 weeks thing. Okay, they have to this work need to pass like this and go this side. Okay, whatever the requirements are there, they have to come from this side and go this side. That's what is the thing. It is a continuous until all these things are completed. Okay, then the work will be done. It is a continuous process. There is no time bound or nothing. Okay, so work in progress limits will be there here. That means, for example, here, for example, if you take this develop block, okay, if there are only 2 developers, they can only work on 4, 1, 2, 3, 4 requirements. Okay, out of all these requirements, okay, based on the priority or whatever it is, okay, from this box product backlog, you can say product owner will create the product backlog. Right here also product owner will create product backlog. This is called as product backlog. The pending requirements that need to be developed and tested by the team. Okay, product backlog will be there. So from this product backlog, the requirements need to be pulled here. But how many requirements need to be pulled depends on number of developers we have. For example, here, if the number of developers are 2, and if you are setting, let's say the number of developers are 2, and if you are setting the limit as 4 here, okay, 2 developers can work on four items at a time. So from this product backlog, we will pull, okay, as part of the project, how many items will be pulled, how many requirements will be pulled. Only 4 requirements, not more than. Okay, it may be smaller, large, based on the capacity, guys. Okay, based on the capacity, not more than 4 cannot be pulled. So this development team will work on these 4 items at this time. Okay, you are not entitled to add 5th item here. Okay, because that is beyond the capacity. Here limits are there for this phase. The limit, development team 2 members are there, so 4 is the limit. Let's say there is only 1 tester, so here let's say 2 is the limit. Only two items can be tested. Okay, so maybe after the development team has completed here, for example, after the development team has completed, let's say this 2 high priority items, they have moved it. So once they have moved, but what is the bandwidth of this development here? Here limit is 2, here limit is 4, but only 2 are there. So what they will do is they will pull from here. Okay, they'll pull the items from here. This product backlog, they'll pull the items. Okay, from the product backlog, they'll pull the items here. Okay, at a time only 4 will be there. If any vacancies are there, they will be pulled from the product backlog. And here, if there are any vacancies, for example, testing team has already tested this one and moved to the done state. In that case, development team, whatever the requirement that is ready, will move here. Okay, at a time only 2 items can be there here. Okay, here one vacancy has come. So what they will do? They'll move one of the item from the product backlog to development team. Okay, this is a continuous process, guys. Once it is done, this will move to this side. Okay, so all these requirements will continuously move on to the right side. If anyone is blocked, if anything is blocked, guys, okay, so there is a concept known as dots. They will put a lot of dots here so that everyone focus on this particular story and try to move it to the right side. Okay, so that's what will happen. If any blockages happen also, the entire team, instead of worrying about how much amount of time it is taking and all, they worry about whether the items are being completed in a quality manner. Okay, here quality is very important, guys. Okay, rather than the time. Okay, within the time limit, this much amount of work. This is not the concept in Kanban. That in Scrum, that is a concept. In Kanban, quality is a concept. Which quality the items have to move to the right side. Okay, so they are not forcing the people to overload. Okay, they are not overloading the work. Okay, whatever the limit they are checking, and if anything is blocking, everyone is there to help. Okay, product owner is there to help, business is there to help, development team is there to help, testing team is, everyone will look into that particular kind of item which is not moving to the right side and will move. Okay, so this is what happens in Kanban, guys. Work in progress limits will be there, whether it may be in development stage or testing stage or done state. So pulling the work from the backlog depends on the team limits. Okay, if how many developers are there, how many testers are there, based on that, developer limit will be set and test limit will be set and so on. Okay, so though Kanban way of developing or testing the software is different from the Scrum way of doing the stuff, there are some common things between Scrum and Kanban also. What are those common things? Here also daily stand-up meetings will be there. In Kanban also we have the daily stand-up meetings, but here we call the Scrum Master. In Scrum, we call the person who conducts this daily stand-up meeting as a Scrum Master. But in Kanban, we call that particular person as Agile Coach. Okay, so the name is different, guys. In Kanban, we call the Scrum Master as Agile Coach. Okay, so here also demos with stakeholders will be there. In the Scrum also we demo the things, right, in order to move from definition of done is something like after demonstration only they can be moved, demos with stakeholders. Okay, and here retrospective meetings. Here also retrospective meetings will happen. Okay, so they will right, self motivate them and self check like how much good work they are doing, and they will keep on working. Okay, self improvising teams, you can say. Okay, so these are few things that are common with the Scrum, guys, but ultimately you understood the idea, right? Here there is no particular time limit, and here work in progress limits are there. Okay, here 2 developers means 4 items can be done. Okay, so after if more than 4 will not be assigned here. If any vacancy comes, then only we will pull here. Okay, if any vacancy in the test, we'll pull from here like that, and the work will completed in a continuous way. Okay, after one item is going off, another item will come based on the priorities and all. Okay, so hope guys you understood what is Kanban at a high level in this session. So this much amount of knowledge is enough for any person who want to understand what is Kanban agile methodology. So that's all for this session. In the next session, I'm going to cover another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 281. That is, what is extreme programming? Let me answer. So what is extreme programming? Extreme programming is shortly known as XP. As you can see here, I have written in the circular brackets XP. XP stands for extreme programming. It's one of the agile methodologies. As we already know, there are different SDLC models like waterfall model, prototyping model, RAD model, Big Bang model, agile model, right? V model, and many other. Okay, agile is one of the SDLC models. Under that agile SDLC model, we have different methodologies. Okay, under agile SDLC model, we have different frameworks or methodologies, and extreme programming is one of them. So we already know Scrum, Kanban. Okay, as I already covered them in the previous sessions, as part of the previous sessions in this series. Scrum, Kanban were few of the agile methodologies. Similarly, extreme programming is also one of the agile methodology or framework we have that projects can follow as part of agile. Okay, values and principles. So similarly, we have lean, crystal, and DSGM under the agile methodologies. But in this session, we are only focusing on extreme programming, agile methodology. Okay. So what is this extreme programming, which is shortly known as XP? Okay. So it looks like theoretical, guys. Okay. So it looks like theoretical because in extreme programming, lot of topics are there. Okay. So without this categorization, it's not possible for me to explain you guys like what exactly is extreme programming. At a high level, it is an agile methodology. It's shortly known as XP. But what exactly is extreme programming? Where it is applicable? Which projects, in which projects it is suitable? Lot of things have to. What are the practices that are generally followed uh, in the projects which actually use this extreme programming? What are the values that are followed? Okay, a lot of things are there in extreme programming, guys. Okay, so let's go slow, guys, slow, step by step, and understand each and everything in all the directions of the extreme programming. Fine. So for that, let me expand this XP. XP is a lightweight methodology, guys. Okay, it is a lightweight. Why we call that lightweight means it will not overburden the developers. Okay, if in a project as part of software development, if the developers are using extreme programming, they don't feel overburdened, guys. Okay, that's why the extreme programming is a lightweight methodology. Okay, it's a lightweight methodology where developers are not overburdened with overwork and all those stuff. Okay, and at same time it's responsive. It gives a lot of responsiveness to customer requirements. Okay, so it's very adaptive to the customer requirements. Whatever the customers say, uh, that is given the highest priority. Okay, so very responsive to the customer requirements. That is the next thing that is achieved generally with extreme programming projects. And uh, and one more important point here is in extreme programming, we take the best practices. Okay, we collect all the best practices that have been working well in the past in all the development projects. So a survey kind thing can be conducted on different development projects. In that, whatever the practice that is working in the project, or that kind of practices are implemented in the projects using this extreme programming. And they are not only implemented, guys, they are taken to the extreme levels. Okay, very focused and extreme levels they are taken to. The best practices that are already working in the existing projects or in the past projects, they are collected and taken to the extreme levels. Okay, to get the benefits. So this is what is extreme programming. Okay, so we have to understand extreme programming in different directions. It's not going to overburden the developers. It's going to give a lot of responsiveness to the customer requirements. Okay, and at the same time, it's going to follow a lot of best practices that are working well in different projects. And not only collecting the best practices, guys, they are focusing on taking these best practices to extreme levels while building the project or whatever it is. Okay, and which type of projects generally have to use this agile methodology, that is extreme programming methodology? Which projects it is suitable for? It is suitable for small to medium sized development of teams. Okay, if the team size is small team is there or medium sized team is there, in that case only extreme program is generally suitable. And also in some projects what happens is very vague or rapidly changing requirements will be there. Okay, the requirements are keeping on changing and they're very vague and confusing or something. In that kind of thing, vague requirements or rapidly changing requirements, in that case also extreme programming is for such projects also extreme programming is applicable for. Okay, are suitable for. And also some software projects where the new technologies are being used or research projects are being done, there also extreme programming is very beneficial because a lot of best practices which are working already in the different development projects are collected and taken to the extreme levels, right? So this kind of things, it is so much applicable for. Okay, so in extreme programming there are a lot of good practices followed. So what are the good practices? These are all the different good. There may be even more than this list, guys. Okay, so whatever I have come across, I have collected here, but there can be more than this list that I have written here. One of the thing is code reviews, guys. Okay, code reviews are taken seriously in extreme programming projects where pair programming, where two developers will be sitting side by side, and while the one developer is writing, other developer will be reviewing the code, and they will be interchanging their roles, where other person who is reviewing will be writing the code, and other person who was reviewing will be writing the code. Okay, like they will be interchanging, and that is what is code review will be taken seriously. And testing by TDD, guys, test driven development. Okay, test driven development is followed where continuously writing and executing the test cases. Okay, so here in this projects where extreme programming is there, we continuously, as part of testing, we have to keep on writing the test cases and executing the test cases, continuous process. Okay, So test written before even code is written. Okay. So a test means not only the software tester test, the developers also will write tests, right? Unit test, integration tests. Okay. Everyone, developers and testers have to continuously write and execute the test cases. Okay. And these tests need to be written even before the code is written. Even before the code is written, code is ready, the test should be ready. Okay. The test should be ready. Such kind of test driven. Okay. Test will be driving the development process. And here good quality design. Okay. Focus is given to the good quality design. Daily daily good amount of time is spent on continuously working on design, guys. Okay. Design is very important. So this kind of good practices are followed in the projects, because you see all the best practices that are working well in the development projects are collected here. These are few of them. Okay. So which these all these things, these good practices will be taken to the extreme level and done in the they are not taken simply. Okay. They are taken seriously to the extreme levels, and then uh, the project will go on. Okay. Incremental development, guys. Okay. So incremental development means, right, the software will not be developed at a go, instead incrementally. Okay. It will increase in size. Okay. So iterations will be there. Iterations will be there, and after every iteration the software size will increase, right? Some requirements will be done in first iteration, then next set of requirements will be done in second iteration, then the software size will increment, and so on. Okay. And also early, to collect early customer feedback. So when because of these iterations, what happens, some sort of software will be ready, and the customer can actually check the software and give the early feedback. Okay. When the early feedback comes, the development happens well, right? So then continuous integration testing, guys, is also very important. Continuous integration testing, unit tests, integration tests will be written by developers, and they are continuously tested. They are tested several times a day. It's not one time a day. These unit tests and integration tests keep on running throughout the day. Okay. Keep on running throughout the day, and they are generally automated, guys. Okay. For every build, that means frequent checkouts will be there. Developers will keep on frequently checking the code. They keep on checking the code, and for every version of the code they are changing. The unit test, integration tests need to run, and this frequent changes will happen multiple times. Developers keep on pushing the code changes throughout the day. In a single day, multiple times frequently they will push the code, and this code has to be tested frequently again. Okay. So what happens, automation also, it's better to go with automation, right? If it is automated, they keep on running, and defects can be detected early, right? So because of the code changes, because they're very extreme level, whatever they are doing at extreme level, guys. Okay. Code changes they are doing at extreme level. Testing they are doing at extreme level, like that. Okay. That's the thing. Short iterations will be there. Okay. Here I was talking about incremental development where iterations will be there, but the iteration size will be very small. Okay. Unlike other agile methodologies, iterations will be very small, and frequent changes will be done, and tests need to be run very frequently, and because of that automation is required. And coding is very free, as I already told you. The developers have to code very frequently. Okay. Frequent code changes in a day, multiple times they will check in the code. Okay. They'll the new builds will keep on coming, guys. Okay. New version of builds keep on coming. Okay. Because of that changes. Okay. And testing, because of this builds are coming very frequently, testing also has to speed up, right? So continuous regression and testing need to be done. Generally continuous regression testing is not just what software testers will do. Even unit tests are also comes under regression testing. Integration tests come under integration testing. System tests, all the tests which all these levels of tests like unit tests, integration tests, system tests need to be automated and continuously run, because code changes are also very frequent. Code changes are also very frequent, and because of frequency, the defects have to be identified early in because of the code changes, anything got affected or not. For that, testing also should be very fast, and for that, manually if you want to do, you cannot do it, right? All the tests, how can you run it very fast for each and every version? So continuous regression testing is required at the unit testing, integration testing, and system testing level. And for that, all the levels, that is unit, integration, and system, are automated, and they are frequently run to detect the defects early. You see the last point I told you, right? Reducing the defects early. Okay. So unit tests are written way before the programming. Before developers will write the unit tests or integration unit tests before even writing the programming, and continuously run them to eliminate the defects. And automation is generally preferred in this extreme programming, guys. Automation plays a key role in extreme programming, because all levels of test, unit, integration, and the system test will be running continuously because of the continuous code changes and frequent changes. Okay. So defects need to be identified very early. Okay. Then only this extreme programming concept will work. So on the top of all this stuff, guys, right, this much of concept is there behind the extreme programming, guys. Okay. So if you have to explain extreme programming, you have to cover this much of topics. Okay. It follows good practices at extreme levels. Okay. So whatever you remember, you try to explain in the interviews if you come across this question. Okay. So values are your communication is given more importance, simplicity of development is given more important, customer feedback is given more importance, courage, developers have to do the code changes very frequently and testers have to test it. You see, this all happens with a courage. Without courage, how these things happen so frequently, testing, automation need to be done, testing need to be done, development need to be done. Without courage, this will not happen. Respect, okay, lot of respect, like, because respect from the customers or all the directions, because we are following very good practices and all. Okay, so this is what is extreme programming, guys. So hope, guys, you understood what is extreme programming. I know that these concepts are very big, and but you should get a flavor of what is extreme programming. It doesn't mean that every project will follow whatever that I mentioned here. A subset of extreme programming is generally followed. Even I have done a project of extreme programming, but all these things are not followed, guys. Okay, so some things are matching in that project, something are not matching in the project, but if you go and search in blogs or websites or whatever the places right around, okay, different websites have different information on extreme programming, and there are very big articles, very small articles. Okay, you can do an R&D and scientific research on this extreme programming. So much a big topic this is. Okay, but this much amount, if you can digest, then it's all good, guys. Okay, so that's all about what is extreme programming. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 282. That is, how do you perform testing when there is less time? Let me answer. So how do you perform testing when there is less time for it? The simple and straightforward answer for this question is, we cannot perform the entire or complete. Okay, the complete testing cannot be done when there is less time. How can you complete your testing? Okay, complete regression suit, if you want to test, is it possible when there is less time? The simple answer is no, guys. So here is a time where we follow a testing known as risk based testing. Okay, when we have less time for testing, then how do we perform testing? We follow risk based testing approach. That is, we first test the high prioritized testing, whatever the time that is left out for us for performing the testing. In that time, first we have to test the tests or test cases which are high prioritized compared to other test cases. Whatever the test cases which are highly prioritized, those need to be tested first, followed by the next priority based on the availability of the time. So what is the benefit of this approach? Since you cannot do the entire or complete testing or complete regression test cases, you cannot run, but at least since you are following or testing the high priority test followed by the low prioritized or next prioritized test, here risk will be reduced. Okay, the kind of defects, okay, that may get missed or not identified by the testing team, uh, the kind of the defects will not be so critical defects. Okay, because we are testing the high prioritized test first. So if they are working fine, automatically the risk level of the defects also get reduced. Okay, so risk get reduced by this approach, guys. Okay, so if you get this kind of question in the interviews, you have to simply say that we follow risk based testing approach, where we first test the high priority test, followed by the next priority test based on the availability of the time. Because of this, risk will get reduced and will not miss the important defects. Okay, so maybe because time is not there, and if testing cannot be done, some low level defects may be missed. Okay, because we are not given with the entire time. Okay, so hope, guys, you got the answer for how do you perform testing when there is less time. Okay, so that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 283. That is, what is risk-based testing? Let me answer. So what is risk-based testing? So before understanding what exactly is a risk-based testing, we have to first understand what is a risk. Okay, in real world, let's understand, guys. Okay, let's understand the risk in a real world. Okay, so for that I'll give an example. Let's say there is a this is your house or home, whatever you call. Okay, so this house, let's say you are traveling to some place, or whether you stay in the home or whatever it may be. Okay, this every house will have a entrance, right? A door will be there. Okay, gate will be there, door will be there. Why this door? Okay, why you need a door? Because there is a possibility, or there is a risk that a robber may get into your house. Okay, if your house is open, anyone can enter into your house and steal your stuff, right? That's where the doors were got invented. Doors are not enough. Again, you have to lock it. Okay, you have to lock the door. If you have not locked the door and just you have the doors, the risk of the robber getting into your house and stealing the stuff of yours is also there. Okay, and again, just locking is not enough. Okay, the robber may come and break the lock and go away. Okay, there's a possibility that you can install a security cam here. Okay, just to see who is actually coming to your house and doing all this stuff. Okay, there's security cam. This may not stop the robber from getting into the house, but at least after the incident happens, there's a possibility that you can catch the robber and get your stuff back. Okay, like this. This is what is risk, guys. Okay, so what is the risk? So this is a real world example of a risk. Okay, everyone is at risk, right? So of robbery and all. Okay, so here risk is a possibility of a negative or undesirable outcome. There is a possibility of robbery which is an undesirable or negative outcome, right? Where a robber may come here and steal your stuff. Okay, so your house is risky, probably. Okay, so that's in general or real world what is a risk means. In software also, there is a possibility of risk. When when you release the software into the market, there is a possibility of risk that some important critical areas of the functionality may not work. Okay, there may be some critical defects that the testing team may have missed. Why the testing team will miss all the defects that are very important? Why the important functionalities are not working? There may be many reasons, guys. Okay, testers were not given enough time, or there were resource constant, less number of testers are there, but more number of test environments are there. You are unable to test in multiple environments, all the environments, unable to cover all the environments, or budget constraints are there, where because indirectly when budget is a constant, time will be a constant, and resources will be the constant. And due to all this stuff, guys, what happens? The software will not be tested properly and will be released as it is. And the customers who are actually purchasing the software and using them for their daily use, right, will come across some kind of important areas of the software as not working, and they are unable to use the software. Okay, this is what is the risk is all about. There is a possibility of risk. Okay, so the customer will reject your software, and your sales will go down. That is a risk. Okay, your sales will go down and no one is willing to purchase. Your business reputation will go down. All these are the possible risks, guys. Okay, even there's a possibility where someone may file a case against you because whatever the product you have sold is not tested well or something. Okay, so and many other things. Okay, so so to how to overcome this problem, there is a possibility of risk for sure, but how to overcome this problem in software before releasing the software into the market, due to some constant like time constraints, or okay, whatever the when to perform this risk based testing. Okay, generally when we have some time constraint or resource number of resources constant and environments are more, budget constraints, many other reasons, whatever it is, we have to perform risk based testing. That means the important areas or functionalities after of the software, okay, need to be tested, which need to be tested first before releasing into the market, before releasing software into the market. Whatever the areas are criticalities of the application or impactful areas of the application, which need to be tested first, which need to be tested, are really tested or not. Okay, the major important critical areas of the software need to be tested first, right? If there are some problems in the major important critical areas of the software, and software is as it is released into the market, what happens? Immediately rejection comes from the customers and all the risk factors happens. Okay, so this may happen when time is a constant, or resource is a constant, or budget is a constant. So in that kind of situation, the projects where time is a constant, resource is a constant, budget is a constant, we perform risk-based testing. How do we perform risk-based testing? So here guys, the concept is prioritization. Okay. So the idea is prioritization. You have thousands of test cases, but if the time is a constant, can you run all the thousands of the test cases? Is it possible in less time? No, not at all possible. So what you will do? You have to spend some time in, okay, before you start testing guys, okay, when before this kind of situation comes where you have less time and you have to perform testing, before the situation comes, way before, I can say, you have to prioritize your tests. Not only prioritize your tests, you have to prioritize your areas of the application. For example, login functionality is there, logout functionality is there, search functionality is there, contact us functionality is there. Okay, a lot of functionalities will be there in the software, but not all functionalities have the same priority, right? They don't have the same risk level. Login functionality has higher risk level than the contact us. Okay, register account has higher risk level. Okay, search functionality has higher risk level. Like that, we have to investigate and we have to analyze all the areas of the application and decide the risk levels of different areas of the application. Okay, risk levels of different areas of the application we have to analyze, and accordingly we have to prioritize our tests and areas of the application. We have to prioritize the features or areas of the application, and also the test cases that are tests also we have to prioritize. So if you do this prioritization and based on this prioritization, if you perform testing, that is called as risk based testing. Why we are calling this kind of testing which is following the prioritization of the features and tests for performing the testing as risk based testing? Because when you test high prioritized tests, the most important critical areas of the application and the most important critical major important test cases when you are testing first, and the defects, okay, the defects are identified faster in these areas, means automatically the risk of the software failure in the market will get reduced, right? Important defects are fixed first, means identified and fixed first, means the risk level of the software rejection in the market after releasing that into the market gets reduced. That is what is the advantage guys. Okay, risk of releasing the software with risky defects will be reduced based on amount of testing done. Okay, because time is a constant. If you have a lot of time, okay, then no problem, right? You will test everything and you will make sure that no defects, it may be important or non-important defects, whatever it is, critical or uncritical defects, you will test everything and you will make it fixed and get it released. But here situation comes where time may be the constant, resource count may be the constant, okay, budget may be the constant, other things may be the constant. Because of that, if you are not planning your testing well, if you are not testing according to the priority of the features and tests, there's a possibility that important critical defects may be missed by the testing team and the software will be released as it is, and you see important critical areas of the functionalities of the application may not work properly for the end users or customers, and they will simply reject and you will have a lot of risk. Okay, so by this risk based testing approach, we are reducing the risk of failure of the software after it is released into the market. Simple words. Okay, so hope guys you understood what is risk based testing in this session. So that's all for this session. In the next session I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 284. That is, what is build acceptance testing? Let me answer. So what is build acceptance testing? Build acceptance testing is nothing but smoke testing. Both are same guys, okay? So you can either call it as smoke testing, build acceptance testing, both are same. So what is build acceptance testing? Here in build acceptance testing or smoke testing, we test the major, important, critical functionalities of the software at a high level in very less time. Okay, so we should not be taking more than 15 or 30 minutes. In that 15 or 30 minutes, based on the type or complexity of the application, we should be able to test the major important critical functionalities. Okay, the important functionalities of the application, that too at a high level. Should not test all the test cases of the important functionalities, only the high level, that is important test cases of important functionalities, you can say in simple terms. Okay, so and that too in 15 to 30 minutes you have to complete your testing. And what is the use, what is advantage of performing the smoke testing? Smoke testing is generally, smoke testing or build acceptance testing is generally done once the developer gives a build for testing for you. Okay, this is the first testing, guys. Okay, this is the first testing that any tester has to do before performing any other testing on receiving the build from the developers. Okay, on receiving the build from the developers for testing, the first testing that software testers have to perform is smoke testing, that is build acceptance testing, and that too we have to complete in 15 or 30 minutes, where we have to test the major important critical functionalities of the application, and at a higher level, that is only the important things of the important functionalities we have to test. Okay, otherwise it will take a lot of time. So what is a use actually? So before you proceed for in detail testing or in-depth testing, we have to make sure at the build level, is this particular build suitable for in-depth testing or not? Okay, question mark. So if it is not suitable, we have to reject the build. Okay, if major important critical functionalities when tested at a high level are resulting in some defects, that means that build is not suitable for in detailed or in-depth testing. Okay, testers cannot proceed for the in detail or in-depth testing. So what the testers will do? Testers will simply reject the build by putting an email back to the developer stating that we have performed smoke testing on this most important critical functionalities of the application at a high level in um, so that is nothing but smoke testing we have done, and we observe that the smoke testing has failed due to so and so defects, and you can put the list of defects in that email. Hence we are rejecting the build and we'll be waiting for the next build which can pass our smoke testing, so that we can proceed with our in detail testing. Like that, we'll put an email to the developers back and reject the build. Okay, if in case smoke testing or build acceptance testing fails. But if the major important critical functionalities of the software when tested at a high level are working fine, then we'll accept the build. No need of putting any email. Okay, we'll simply accept the build and simply proceed with the other testings. Okay, in-depth testing and whatever the testing that we have to do as software testers on the received build from the developers, we have to perform, guys. Okay, so this is called as build acceptance testing, which is nothing but smoke testing, which is generally performed first once we receive the build from the developers. Okay, so hope guys you got the answer for this question. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 285. That is, what is sign off report? Let me answer. So what is sign off report? Sign off report is also known as quality report or test summary report. Okay, there are different names for this sign off report. So what is the purpose of the testing team to create this sign off report? So let me explain the purpose. So this is generally created by the testing team, okay, and used in a formal way to declare the completion of testing. Okay, we have completed our testing, and we by that, by stating that we have completed our testing, we provide our approval or judgment for releasing the software into the market, guys. Okay, so by using this sign off report or quality report or test summary report, the testing team will formally send an email to all the other stakeholders in the team, okay, just to declare stating that we have completed our testing on the build, and this particular version of the build, okay, either we approve the build, okay, we approve the build, okay, this you can release this particular version of the build into the software because the quality is good, we are approving it. Or sometimes what happens is we judge the quality of the build. Okay, we reject the decision of releasing the software into the market. Okay, we can also use a sign off report or quality or summary report to give our judgment on the current quality of the software. Okay, we can either approve or judge whether we can release the software into the market, and this report will be created by the testing team to formally communicate, because the orally communicating will not stand, right? If you orally say 100 words, it doesn't matter in the team. Okay, tomorrow if something happens, everyone will come to the testing team and say what happened, why you have missed this particular defects, and so on. Okay, how can you, okay, how can you simply let us release the software into the market, they will ask us. Okay, so to avoid that, to avoid getting into that kind of cornering situations, what we do is, as testing team, we create this sign off reports or quality reports or test summary report, we can call it anything, where we formally declare our judgment or approval status, okay, based on the current quality of the software, and if it can be released into the market, we give our judgment as you can release into the market. Okay, otherwise we'll simply say that this particular version of the software even though it is better than the previous version, we are not recommending this for release because of so and so defects in the software, like that. Okay, so I'll give an example, guys. Okay, rather than explaining this much of theory, let me give an example, guys. Okay, here is the example. So here is an example, guys. Okay, quality report or test summary report or sign off report, whatever you call. So for a sample application, so there are only three items here. You see quality status, we are giving our judgment, approval status or judgment status we are giving. And we are stating that we have tested in all the test environments, and are there any existing defects still left before releasing the software into the market. That three sections we are simply providing. Quality status, what is the current quality status? We are simply saying that quality of the, this one example only, this one example template. Again, different companies use different templates. Don't think that the same template will be used across all the companies. So this is one of the template which can be used by one of the companies. Okay, like that. Okay, the quality of the tutorials ninja application, so and so version is better than the previous versions. In this version, the important issues are still there, and hence we are not recommending this version for release. Okay, if the important defects are not there and only minor defects are there, we would have recommended this version for release. Okay, by stating that apart from this minor defects, we are approving this particular thing build for release or something, we would have seen that. But here in this case, in this example, what's happening? Okay, though this version is better than the previous version, but there are still important issues which need to be fixed by developers and not yet fixed by developers. Hence, we are not recommending. The testing team is giving their judgment here. Okay, okay. Otherwise, we would have given our approval. Okay, since approval cannot be done for the releasing of software into the market, we have given our judgment as not recommended this version for release. Okay, so and to prove that we have completed our testing. Okay, so we have provided all the list of test environments supported by the application, and where the application need and must have to be tested. Okay, all these environments we have tested completely, and these are the defects by functional area. This is optional, guys. If you want to make it the report look good, you can use this kind of diagrams. Okay, in Word document you can actually get, or in a Excel files also you can create and copy paste the images here. Okay, so different ways of creating this image. So here in which areas the defects are there, like that. You can even make it more complex, guys. Okay, I have made a simple diagram here. So criticality of the defects and functionality also you can create if you want. Okay, if you want to make an impact. Okay, that is also a good idea. So what are the list of defects which are still not fixed by developers and still there in the current version of the software, and the reason behind why we are not recommending this particular version for release? That all the list of defects we have provided here. You see in that these are minor, that's okay. Major defects are there, critical defects are there. When there are critical and major defects, how can they release the software into the market? So we are opposing that as a testing team. Okay, so this is what is called as sign off report or quality report or test summary report. There are different names. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 286. That is, what is test summary report? Let me answer. So what is a test summary report? Test summary report in some companies is also known as sign off report or quality report, guys. You can either call it as test summary report, sign off report, or quality report. Okay. So what is the purpose? Why the software testers have to create or prepare such kind of test summary report? Okay, what is the purpose? So what the testing team will do is, when the testing comes to the end, and when there is a situation where the software has to be released into the market, all the stakeholders are already discussing about let's release this particular version of the software into the market. Okay, such kind of situation, what the testing team will do is, they will prepare this test summary report or sign off report or quality report, whatever you can call. Okay, so to formally communicate to all the stakeholders, okay, that they have completed the testing. The testing team has completed the testing is one thing that they want to communicate, saying that we have completely tested the application. That is one thing. Second thing is, here we are, if the quality of the current version of the software is very good, okay, if testing team also believes that the current version of the software is very stable and can be released into the market, then approval, okay, the testing team can provide approval in the form of this report. Okay, and third thing is, so there may be some situations where the stakeholders may decide to release the software into the market. Okay, to release the software into the market, but testing team knows that there are still some critical major defects still available in the software. How can the team release? In that case also, the testing team may formally create this test summary report and formally communicate to all the stakeholders, providing their judgment on whether the software can be released into the market or not. This is what is test summary report, guys. Okay, this is what is test summary report. When the testing comes to an end and the stakeholders are in a situation of releasing software into the market, either we have to provide approval or we have to give our judgment in a formal way. Okay, for that we have to prepare a report known as test summary report. Okay, I'll give an example, guys. There is an example report. So I already opened that link here. So this is the quality report or test summary report or sign off report, whatever you can call it. Okay, for this particular application, we have created the report. So there are three items here. This is one of the template, guys. Different companies may use different templates. Okay, so this is one of the template that one of the company may use. Okay, don't think that all the templates in all the companies will be same, but this is one sample, you can say. So here, as part of table of items, you see table of contents, quality status, test environments, covered list of existing defects is provided. First of all, quality status, whether the software testing team is recommending the release of the software into the market or not. Okay, here we are not recommending, guys. In this sample one, in this example quality report, we are not recommending, saying that the quality of this particular application having this version as 13.56 is better than the previous versions. Okay, in this version, the important issues are still available. Okay, whatever the important defects are there, they're still available, and hence we are not recommending. Okay, since there are some important critical defects available in this particular version of the software, we as software testing team are not recommending this version of the software for release into the market. That's what we are stating here. And also at same time we are communicating, saying that we completed our testing though. Okay, though we are not recommend this particular release for into the market due to the important defects, but here we are indirectly stating that we have tested in all the test environments. Our coverage is done, our testing is done, guys. We have tested in all these available or supportable or must and should tested environments. Okay, all the list of environments we provided. And also, just to create an impact, why we are not recommending this particular version of the software for release, we can create a lot of diagrams, guys. We can get this kind of diagrams in Excel sheets, or and you can copy paste the images here. You can make it even more impactful. Okay, this is a very simple diagram. In which functionalities how many defects are there. You can also raise the bar, saying that in which functionalities important defects, critical defects are still left out. Like that also you can, that's a good idea. Okay, you can improvise this diagram if you want. Okay, this is just a template, guys. Okay, and also here we have mentioned the list of defects that are still available in the software. Okay, which need to be fixed by developers. And most of the defects are minor defect, but as you can see, some major and major defect is there, critical, major. Okay, like that, somewhere here and there some major defects are there, guys. Okay, 4 to 5 major defects are there, one or two critical defects are still there. That's the reason we are not recommending this particular version of the software to be released into the market. Okay, this is what is test summary report, sign off report, or quality report, whatever you call, guys. So hope, guys, you got an idea of what exactly is a test summary report in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 287. That is, what is a production server? Let me answer. So, what is a production server? Once the developers and testers build the software and perform testing, and when the software is ready for release, okay, after the developers have built the software and after the software testers have confirmed that the quality of the software is good and is ready for release, then that particular build, okay, that build website content will be deployed onto a server. Okay, that particular build website, which is properly developed and properly tested by testers and developers, will be deployed onto a server machine. Okay, and hosted onto the production server. That's what is a production server. Okay, a server machine where finally the code will be deployed. Okay, the developed and working code will be deployed is called as a production server. Okay, it is a server machine, guys, where the developed and tested website content, okay, which were properly developed and properly tested website content will be hosted, is nothing but the production server, which is a server machine. It is a live environment, guys. Okay, it's a live environment. Why we call that as a live environment? Once this particular website content is hosted onto this server machine, a final server machine, okay, all the end users around the globe can access the application for their daily needs. Okay, that's what is a production server. If the production server goes down, then you cannot access the application. Okay, I'll give you an example, guys. I will give you an example. For example, if you take Amazon.com, okay. So at present, you are as an end user, I'm able to access Amazon.com because the website content of this Amazon.com, which is properly developed by its developers and properly tested by its testers, has been hosted onto a server machine known as production server. Okay, that's why I'm able to access. Hope you are able to get the point now, right? So it is a live environment from which or from where all the end users can access application for their daily needs. If that particular website content is in the tester's machine or developer's machine, no one around the globe can access. But if that website content which is properly developed and tested by testers and finally deployed onto a server machine, a final server machine known as production server, okay, which is also called as a live environment or live server, then all the end users around the globe can access the application for their daily needs and use. Okay, that is what is production server. So hope guys you understood what is a production server. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 288. That is, what is live server? Let me answer. So what is live server? Once the developers build the software and later when the testers certify that that particular software build is ready for releasing into the market, then the build website content, okay, then the build website content is deployed and hosted onto the live server machine, okay, a machine known as live server. So that is what is live server, guys. Okay, once the development is done, once the testers certify that the quality of the software is good and can be released into the market, then all the stakeholders will decide to release the software into the market. In order to release the software into the market, the website content need to be deployed and hosted onto a final server machine known as live server. Okay, it's known as live server. So here it is a server machine, guys, where the developed and tested website content is hosted. Okay, deployed and hosted. That is what is a live server. It's a live environment. Why we are calling that as a live environment? Why we are calling the live server as a live environment? Because once this website content is hosted onto this live server, then all the end users around the globe can access the website for their daily uses and needs. Okay. So for example, if you take any website like Amazon.com, okay, here as an end user, I'm accessing this website. In order for me to access this website, okay, the development team and testing team have already developed this Amazon.com application well and tested it well and deployed the website code, content, and other files related to the website onto the live server, okay, and hosted it, okay, and hosted it there. Then only we'll be able to access this kind of websites, okay. So that's what is a live server. We can also call the live server as a production server. Okay, we can also call, sometimes some people will call it as production server, some people will call it as a live server. Okay, it has different names. So hope guys you understood what is a live server in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 289. That is, what is recovery testing? Let me answer. So what is recovery testing? In recovery testing, the testing will be performed to check whether the software, that is system, can recover from failures and crashes. If a particular software is failed or crashed, okay, and later when you open the software, is it recovered properly or not? We check as part of recovery testing. Okay, I'll give some examples for the recovery testing. So recovery is being done properly or not is checked in recovery testing. Okay, when a software or system is like exposed to some failure or some crash, whether that particular software or system is getting recovered properly or not is tested as part of recovery testing. Whether the work is resumed in specified time limit on recovery or not, because there may be some mission critical applications, okay, army related application, okay, if that is crashed, it should resume very fast, it should recover very fast and resume very fast, and work should not be interrupted, data should not be lost, Okay, all such kind of cases will come in recovery testing, guys. Okay, what will cause the failures? Okay, what are the different reason why the software goes through these failures or crashes? Okay, one of the reason may be power supply failure. For example, you are using your system doesn't have a backup. Okay, and suddenly the power got off. Okay, power gone. Then what happens? System will suddenly shut down. Now, after the power comes, now if when you are opening the software has suddenly went through a kind of crash or failure, guys. Okay, it suddenly got shut down without any instructions. In a in a non-proper way, it got shut down, right? The software went down in a non-proper way. Suppose, okay, after starting the machine, when you again open the software, is the software is capable enough in, okay, capable enough in, okay, so overcoming that problem, okay, overcoming the problem and able to recover properly and in less time without losing the data. Such kind of all things can be tested, guys. Okay, one of the cause may be power supply failure, guys. When the system goes down and software recovers despite of it, okay, is tested here as part of recovery testing. For example, Word document, guys. Let's say when you are working on a system which doesn't have a backup, let's say, and you have opened a Word document and you started typing something into the Word document, and suddenly the power went off in your area and you doesn't have a backup. What happens? The system shutdowns. Because of the system shutdown, this Word document also goes down in a non-proper way. And again the power came and you started your machine, and your machine related software also has to go to recovery process, because even the operating system level also, okay, whether it is Windows or whatever it is, because of the sudden power off, okay, it has to cope up the power problem, and has to recover it, okay, recover the files without losing the files. And also this Word document, when you open again, it should give us some options to recover the data without the data that we were actually typing, important data that we were typing. We have done a lot of hard work without saving the document or whatever it is. So the data should not be lost. The Word document has to give you some options where do you want to restore the data or not. If you select restore, the data should come back. Okay, such kind of testing is done in recovery testing, guys. Okay, one of the cause is power supply failure, other is network signal loss. Okay, so you are downloading a movie, guys. Okay, let's say for example, there is software using which you are downloading a movie, and when you are in middle of the movie, middle of downloading of the movie, suddenly your network went off, your network got disconnected. Okay, your internet network got disconnected, and again in a 1 minute or 5 minutes again the network came back. So the software should wait for the network to come back and should not start downloading the movie from start, rather it should continue the downloading. Okay, so such kind of thing is there or not can be tested as part of recovery testing. Okay, restarting the system. So you see the sometimes due to some reasons we have to restart our machine, and our browsers have lot of sessions already open. So you may be in a kind of situation where if I restart, all the sessions will be gone. Okay, so despite of that, when you restart the machine and when you open the browser, if the browser is giving you the options to restore all your previous sessions, okay, without losing your previous sessions, okay, all your previous browsing sessions are being recovered properly or not, you are taken to the proper websites or not, okay, that you are already working on in the browser before restarting the system, can be tested as part of recovery testing. Website crashed. Okay, so there may be some situations where the website may crash, guys. Okay, if, when the website crashes, guys, or goes down, or the server of the website goes down, we have to restart the server, and the work should be resumed properly without any problem after restarting the server, or when website crashes, when you open it again, it should work fine without losing the data and all those stuff. Okay, that also comes under recovery testing. So how do we perform testing? How do we perform this recovery testing? So it is a natural process of power going off or network signal lost, right? But while testing recovery testing, we intentionally plug off the system. We intentionally disconnect the internet. Okay, while using this, while downloading the movie for testing the software, we intentionally disconnect the network signal. Okay, like that. All these things we generally intentionally do to perform recovery testing, guys. So hope guys you understood what is recovery testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to explain the difference between sanity testing and regression testing? Let me answer. So, what is the difference between sanity and regression testing? Let me first explain about regression testing and later I will cover sanity testing in comparison with the regression testing. So, in case of regression testing, the regression testing is performed to check whether there are any side effects which got introduced into the existing working functionalities of the software when developer has done some code changes. So let's say there is a developer and there is software. Developers keep on changing the code, right? There are several reasons why the software code get changes. Maybe bug fixes, okay? Due to bug fixes, developers have to change the code in the software. Maybe developers may have to implement some new features in the software. For that, again, developers have to touch base the code. They have to change the code. Maybe the existing features need to be updated. Updated means modified or removed or whatever it is. Okay. Or existing feature need to be enhanced. Okay. It has to be taken to the next level. In whatever the reasons may be, guys. Okay. Whatever any of these reasons may be, developers have to change the code. When developers change the code in one area of the application, that impact can happen or it may result in side effect in any other areas of the application. As software testers, we are not sure, okay, which area of the application in the software got affected or impacted because of the developer code changes. So let me take a real world example, guys. Okay, you went to a doctor. Okay, you went to a doctor, and what is the reason you went to the doctor? You got a headache. Okay, just because you got a headache, you went to the doctor. Okay, you are getting severe headache from last few days, and you went to the doctor, and doctor has prescribed you some medicine. Okay, and asked you to use for 1 week. And okay, so you went home and started using that medicine given by the doctor for 7 days, and your headache got cured. Okay, your headache got cured. Now your stomach started paining. You see, the problem was there with the head, but when doctor has suggested you the medicine for the headache and you have taken the pills for the headache, now the problem has now come in the stomach. Your stomach started paining. Okay, again you went to the doctor. Doctor. So you gave me the tablets for headache. I have used it. My headache is now completely gone, but I got stomach problem. Okay, this is what is happening. In case of software also, if any code changes have been done in any area of the software, other areas may also get impacted. We don't know which area of the application will get the side effects or will get impacted. We don't know. That's the reason the software testers will perform regression testing where the existing in the previous version of the software, all the areas of the application which are working, if they are working also, still will check in the still will check them in the latest version of the software, because at some place developer has done some changes, and as software tester we don't know which other area of the application got impacted. Okay, because of a small change in the software also, any other area in the software, any other area which is working earlier, okay, fine, also may get impacted. They may get side effects. So that's the reason we perform regression testing on all the areas of the software in depth, okay, to see if there are any side effects in the existing working functionalities of the software. Okay, fine, all the functionalities are tested in depth, guys. Okay, irrespective of whether they are impacted or not, we don't know. Okay, developer says that okay, these areas may get impacted, but we don't believe the developer. Okay, so the area got changed. That means in the latest version, complete regression testing, complete areas of the application we test to see if there are any side effects got introduced into the existing working areas of the software. Now come to the sanity testing. Okay, coming to the sanity testing, here only the impacted areas of the application are tested. Here in regression testing, irrespective of whether impacted areas or no, we have the knowledge whether this is impacted or not. Irrespective of that knowledge, we are testing all the areas of the application to see if there are any side effects because of the code changes. But in sanity testing, it is not like that. Okay, so developer may tell you in advance that I'm changing the code here, and because of this so and so XYZ areas of the application may get impacted. In sanity testing, we test those areas of the application, including the code changing area, and along with the impacted areas. Because of the code changes, whatever the other areas are getting impacted, right? Those are also need to be tested in depth. Like regression testing also in depth only will perform. Sanity testing also in depth. Test cases related to the code changed functionality and impacted areas of the functional application that developer has suggested you. Those only the impacted areas we are testing. We are not testing the entire application here. Okay. Here also changes may happen because of the new functionalities, bug fixes, existing feature updations, modifying the functionality, removing the software, updating or taking the software to the next level, or bug fixes. All this same reasons. But here all the areas of the application, whether they are impacted or not, are tested to see if there are any side effects. But here only the impacted areas of the application that are recommended by or suggested by developer to test in depth are tested, guys, including the code changed functionality. Okay, only those impacted areas are tested in depth, guys. That's why sanity testing is a subset of regression testing. Here also we are testing in depth. Okay, here also all the functionalities of the application we are testing in depth. Here also only the impacted areas of the application also we are testing in depth. Okay, we use the same test cases. Here also same test cases. Okay, test cases of the impacted areas of the application. Here test cases of all the areas of the application will test. Okay, that's what is the difference between regression and sanity, guys. Okay, in regression entire application functionalities will be tested irrespective of whether they are impacted or not, to see there are any side effects. In sanity testing, only the impacted areas of the application are tested in depth. Okay, and it is a subset of regression testing. So hope, guys, you got the answer for what is the difference between sanity testing and regression testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 291. That is, what is end-to-end testing? Let me answer. So what is end-to-end testing? If you take any software system, okay, for example, if I take a software system like this tutorialsninja.com/demo, this software system is an e-commerce application, okay? And it is a complex one. It's not a simple application, guys. There are a lot of functionalities in this particular software: wish list, shopping cart, checkout, and you see a lot of items are there, add to cart. This is a complex system, guys. Okay, if you break down this complex system, okay, every complex software system, this is an example for a complex software system. Every complex software system comprises of what? Several subsystems. What are the subsystems? For example, in this complex application, the subsystems may be login. Login functionality may be a subsystem. Register account may be a subsystem. Wish list may be a subsystem. Okay. Add to cart may be a subsystem. Shopping cart can be a subsystem. Like that, it involves a lot of subsystems, guys. Okay, a lot of subsystems collected together will become the whole software system, whole complex software system, right? So in case of end-to-end testing, okay, in case of end-to-end testing, okay, it is performed to check the working of the real-time end-user scenarios or flows covering multiple interconnected subsystems inside the whole system. So if you are testing only the login functionality, you are not worried about register account or search functionality or placing an order. Okay, if you are not worried, only login related functionality, if you are testing, just give some email address, some password, valid password, and click on login, and you are able to log in or not. One test case is completed. Second test, okay, let's say second test, I give valid email address and invalid password, and it's not allowing me to login. If I am testing only this login subsystem of the software, it cannot be called as a end-to-end testing. Okay, in the entire complex software system, there are several subsystems. Login is one of the subsystem. If you are testing only that login subsystem, we cannot call the testing as end-to-end testing. In end-to-end testing, we check the working of real-time end-to-end user flows covering multiple interconnected subsystems inside the whole system. I'll give an example, guys. Okay, how subsystems together can be tested. Okay, to replicate or simulate the real-time use, the way the end user uses the software in real time. Okay, that kind of testing we have to do, guys. Okay, which actually involves interconnection of lot of subsystems in the software. For example, here, guys, what I want to do is I'll first log in. I'll first log into the application. After login, I'll search for a product. Okay. Second subsystem came. Search is login is completed and login is interconnected with the search now. Okay. Click on search. After search, search results came. Another subsystem came. Search result subsystem came where some product is displayed. Click on this. You are taken to the product display page, which is another subsystem. Okay. You see a lot of subsystems are getting interconnected, and I am following a kind of scenario that a real user for his real for his or her real needs will use in real time. Okay. So after going there, after checking the details, add to cart, and then we'll go to the shopping cart, another subsystem, and we can update the quantity if I want, or we can do all the stuff. Okay. I'm just going at a high level here. Okay. So I'll select the billing details, I'll select the delivery details, I'll select the delivery method. You see how many subsystems are there. I'll select the payment options, cash on delivery. Only one option is there, so I'll go with the cash on delivery. And finally, I'm placing an order also. This is what a real user will do. User will just not log in and come out of the system, right? That will not become end to end. Okay. In real time, the real user will use a kind of scenario, okay, for his real needs, where the user may want to log into the system, search for a product, add that product to the cart, and update the details, address details and all, and finally place the order. This is what a real user want. This entire thing which is interconnecting the lot of subsystems in order to place the order. Okay. If you are testing as a software tester, okay, that testing is called as end-to-end testing. So hope guys you understood with an example. Okay. End-to-end testing is performed to check the working of the real-time end-to-end user scenarios or flows, covering multiple interconnected subsystems inside the whole system, whole software, whole complex software. Okay. Example I already gave, like starting from login to placing an order, we covered an end-to-end flow that real-time user will use in real time. Okay. So this is what is end-to-end testing. So software testers have to focus on this end-to-end testing, guys. Okay. Because tomorrow end users are going to follow the same scenarios. If you don't perform end-to-end testing, tomorrow when end users use that interconnection of the systems, and if things are not working and there are defects, that will be missed. Okay. So that's the importance of the end-to-end testing, guys, that every software tester have to perform end-to-end testing, thinking in the direction of the end user, how the end user is going to use the software with the interconnection of multiple subsystems in our whole software system. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I'm going to answer software testing interview question 292. That is, what is ETL testing? Let me answer. So what is ETL testing? ETL stands for extract, transform and load. Okay. The full form of ETL is extract, transform and load. And it is used in data warehouse projects for performing. Where is ETL generally used? ETL softwares are generally used in data warehouse projects for performing. First one, extract. Extracting the data from different data source. Okay. From a different data source, you are extracting, pulling the data. Okay. That is extract. Transform means conversion. Okay. So there are two things, guys. Okay. So one data source is there. That is source data source is there. Source data location, you can say. Destination data location, you can say. Okay. Both are in different formats. Okay. Now from the source, you have to extract the data, convert the data according to the destination, and push the data into the destination, load the data into the destination. This is what is all about ETL. All the tools around ETL are doing the same thing, guys, for data, for the projects which are having this data warehouse where lots and data are being stored. Okay. So the database size is very big in this kind of projects where data warehousing is there, right? So in this case, ETL tools are generally used, guys. Okay. Extract, transform, load are the activities generally done by the ETL tools, where E means extracting the data from different data sources, from the source data source, pulling the data, and transforming means converting the data according to the destination data source. Okay. Destination data type, you have to convert. Okay. You cannot directly load the source data into the destination data because they may be of different types. Okay. So transform or apply the calculations on the extracted data from whatever the source data is there, right? That extracted data, you are transforming or applying the calculations as per the destination data requirements. Okay, according to the destination data requirements that we can load into the final destination, we have to transform the data. T stands for transform, and finally load the data. Once it is transferred, converted, then load the transform data into a data warehouse. Okay, into the project having the data warehouse. Okay, so the data will be very hectic and heavy kind of data, guys, in these projects. Okay, extract, transform, load. That's why tools are being used to in a bulk to extract the bulk data, transform the bulk data, and load the bulk data. Okay, so that is what is ETL. But what is ETL testing? ETL testing means testing whether the data is properly extracted from the source, properly transformed according to the destination, and properly loaded into the destination. All these things are done properly or not. If you are checking or testing, that is called as ETL testing. Testing whether the data is properly extracted, transformed, and loaded into the destination data warehouse. Okay, of the project is known as ETL testing. Okay, at a high level, guys. Okay. So hope guys you understood what is ETL testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 293. That is, what is extreme testing? Let me answer. So what is extreme testing? In order to understand what exactly is extreme testing, you have to first understand what is extreme programming, which is shortly known as XP. What is this XP or extreme programming? You see, there are different SDLC models like waterfall model, prototyping model, V model, RAD model, and agile model, and other models. Okay, agile is one of the SDLC model. Under agile SDLC model, there are different methodologies and there are different development methodologies and frameworks, guys. Okay, so some of them are Scrum. Okay, Scrum is the number one in the market now. Okay, followed by Kanban, which is also famous. Extreme programming is also being used in the projects. Okay, these are different methodologies or frameworks, development frameworks, which fall under the Agile SDLC model, Lean, Crystal, DSDM, and so on. Okay, so extreme programming is one of the Agile methodology. That is the first thing. And here, extreme programming is shortly known as XP. So, what happens in XP? Okay, what exactly is XP? So it is a lightweight methodology, guys. First of all, XP is a lightweight methodology. Okay, it doesn't over. Okay, there is a small movement I have to do here. Just give me a second. Yeah, yeah. First of all, what is XP and why it is so special and all those stuff. Okay, so it is a lightweight methodology, guys. Lightweight methodology means it doesn't overburden the developers. Okay, developers, you see, always they say that we are not getting time, we are not getting time. Okay, we are overburdened with lot of work. Okay, if this extreme programming agile SDLC methodology is followed in the projects, then they are not going to get overburdened. Okay, that's why this methodology is called as lightweight methodology. Second thing is responsiveness to customer requirements. Customer requirements are given utmost focus. Okay, so a lot of response is given to the customer requirements. Okay, so everyone discusses about the customer requirements. Okay, a lot of whatever the customer says we do. Okay, without worrying about and all, because here customers are like, right, whatever the requirements say at any point of time in the project, we accept, we give proper response to the customers. That's the next one. And third one is takes the best practices. This is very important point, guys. Extreme programming takes the best practices that have worked well in the past in all the other development projects. Okay, if you take all the collection of development projects that are done in the past, and in those, if you take an average, you can collect a lot of best practices, right? Okay, in this project, this was something that is very good. Okay, in other project, this particular development practice is very good. Okay, all those best practices in the development, okay, are put into one project and are not only put into the project, but they are done in the project at extreme levels. Okay, they are done in the projects at which level? Extreme. They are taken very seriously and taken to the extreme levels, guys. Okay, that's what is extreme programming, without overburdening the developers, without hurting the customers, by being responsive to the customer requirements, and also collecting all the best practices of development which are working well in the other projects, and utilizing them in our project where extreme programming methodology is being followed, and also implementing them at extreme or serious levels. Okay, that is what is extreme programming, guys. For which projects extreme programming is applicable? Okay, that's another question. For small to medium sized development teams, okay, in projects where the team size of the developers is small to medium, okay, they are not very big development teams, small to medium sized development teams are there, then extreme programming is applicable. And second thing is, in some projects there are vague or rapidly changing requirements. Okay, the requirements are rapidly changing, guys. Okay, they are not constant, and they are very vague, and okay, not easy to understand and all those stuff. Okay, in such cases also extreme programming. And also there are some projects where new technology or research projects, okay, so something new is happening that no one is aware of, such kind of projects. Okay, technology, it may be technology or it can be research, something that is happening new. In for such projects also extreme programming is suitable. So what in extreme programming, guys, as I already told you, we take the best practices from all the different development projects that are working out in the market, and take them to the extreme levels, right? Here, there are few list of best practices, okay, that generally work in the projects. Code review is one of the best practice, guys. Okay, so it can be implemented in projects following extreme programming methodology. Pair programming means two developers will be sitting before the machine. One developer will be writing the code, other developer will be reviewing the code. After a while, they will swap their positions, where the one who was reviewing will be writing the code, and the one who was writing the code will be reviewing the code. Okay, so such kind of the code review is taken seriously. And here testing by TDD. Okay, in this projects, testing will be done by test driven development. Okay, test will drive the development process. Test driven development, not just what software testers will do, even developers have to do testing like unit and integration testing. Okay, so continuously write and execute the test cases. It can be unit test cases, integration or system or whatever the test cases. The test case need to be written continuously, and executed also continuously, and test. And before the code is written, the test should be ready. Okay, that's what is the thing. Okay, tests are generally written before the code is code is built for developing the code is written for building the software. Okay, so much of test driven development is there. Good quality design, utmost focus is given. Okay, lot of focus is given for the quality design, guys. Okay, design will be checked, design will be worked on daily, guys. On a daily basis they will check what is the design of the software and all those stuff. Okay, continuously they work on the design daily. Okay, incremental development, guys. Incremental development means, what is incremental development? Okay, so incremental development and iterative at the same time. Incremental iterative development, what does it means, for the development happens in the form of iterations, guys, in short iterations here. So there may be some number of days, you can say. And by the end of this iteration, right, by the number of these days, some portion of the software will be ready here. And after the end of the second iteration, the more bigger size software. Okay, incremental. Okay, this is iteration, this is incremental. The software size is getting incremented. Okay, the software is becoming bigger and bigger. For every iteration they're releasing the software, so that they can get collect feedback from the customers, right? If the customers can see something that has been developed, and they check that, and they can give the feedback instantly and earlyly. Okay, so here iterations are there, incremental way of development is there. For every iteration, some sort of the software will come out, and the customers will give you the feedback. So these are all the advantages, guys. Okay, these all good practices, guys. Okay, which can be followed in any project. In extreme programming, these kind of good practices are followed at the extreme levels. Okay, extreme, I mean serious levels. Continuous integration testing, guys. Okay, this is also another important point. Either unit testing or integration testing, test several times a day, guys. Okay, these unit tests and integration tests need to be run continuously, and that too not one time a day, multiple times a day. Unit tests and integration tests are done, because the developers will be checking their code multiple times. Very frequent development will happen, guys. Okay, the developers keep on pushing the code, keep on pushing the code to the repository, central repository. A lot of versions of the code keep on coming, lot of the versions of the build keep on coming, and lot of versions of the build are keep on coming. Some tests should be there to test them, right, continuously. So developers will continuously run the unit test, integration tests, okay, to see whether anything is breaking, or anything is breaking in the software, or any code changes, code push they have done. Okay, at that particular point of time. Okay, so this unit testing, integration are done very frequently. Okay, multiple times a day. And these are generally automated, guys, because you see, developers have to focus on testing the developing the software, right? Checking the code and pushing the code into the repository. That's what is their duty, and they have to do it in a very extreme level and frequent level. But if they focus their time on writing, performing the unit testing and integration testing manually, the time won't be enough. So what they will do is developers will automate this unit test integration test and allow them to keep on running. Okay, they keep on checking the code, and these unit test integration test automation tests keep on running to check whether their check-ins are going well or not. Okay, these are short iterations, guys. I told you here incremental and iterative development. Okay, iterations will be there, but these iterations are not going to be bigger iterations. They are very short iterations. Okay, in very short iterations, some sort of the software will come out. Okay, in an incremental fashion. Okay, code frequency, as I already told you, frequent code changes. Okay, developers will keep on changing the code very frequent, multiple times throughout the day, and they will be checking the code into the central repository. Okay, multiple versions of the build versions of the software will keep on coming out. Okay, for every code change. Testing frequency, because code change frequency is very high, means automatically testing frequency, it may be at unit testing level, integration testing level, even system testing also, guys. Okay, the software testers also have to automate their regression tests and keep them running. Okay, so that means while the developers are keep on frequently checking their code, for every version the automation test should run at different levels, like unit testing level, integration testing, system testing level. All these levels need to be automated, and this test should be keep on running to verify. Why they have to keep on running, guys? To detect the defects early. We have to detect the defects early, guys. Okay, so you, with the help of the automation, we reduce the defects early. Okay, unit tests are written way early than programming, and continuous run tests, that means all level of tests, unit tests, integration tests, system tests, so that they can detect the defects early, and they can be fixed. And automation of these things and other levels of testing for early defect detection is very, very important. Okay, so and also there are some values, guys. Okay, communication is given important. Okay, so communication is given utmost importance in this extreme programming. And simplicity, things should be very simple. Feedback from customers, early feedback, and courage. Okay, here developers and testers take this as a challenge and do their work. Okay, they have to automate, they have to test, they have to develop. Okay, courage, without courage it's not possible. Respect, they respect each other, guys, in the team. Okay, so this is what are the values in the extreme programming, guys. So hope, guys, you understood what is extreme programming methodology in agile SDLC model. One of the methodology in agile SDLC model. If testing is performed in this extreme programming development methodology of agile SDLC model approach, if the test approach followed projects, the projects where this extreme programming methodology approach is followed, if you are performing testing, that testing is called as extreme testing, guys. Okay, extreme testing is approach for testing the applications which are getting developed using which methodology? Extreme programming development methodology. Okay, the testing that is generally performed in extreme programming development methodology is known as extreme programming, guys. The line is very simple, but first we need to understand extreme programming, then you can understand extreme testing, guys. Okay, testing, extreme testing is nothing but the approach for testing the applications which are getting developed using which methodology? Extreme programming agile SDLC model methodology. Okay, agile SDLC model development methodology. So hope, guys, you understood what is extreme testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 294. That is, what is endurance testing? Let me answer. So what is endurance testing? Endurance testing is a type of performance testing. Under performance testing, there are different types like load testing, stress testing, spike testing, endurance testing, scalability testing, volume testing. Okay, where endurance testing is one of the types of performance testing. So what exactly is this endurance testing, and what exactly is performed as part of performance testing under endurance testing is something I'm going to explain. First of all, endurance testing is a type of performance testing, as you already understood, where the application is tested with an expected load for a long period of time to check whether the application can handle that particular load for that period. Okay, so let me give an example, guys. Let's go to an application like amazon.com. Okay, let's say this Amazon, vaguely, guys. Okay, I don't know the figures like how many people daily visit this amazon.com in normal days. Amazon.com, how many people will visit? I'll give a very vague number. Don't take that as a real number. Okay. Let's say 1 lakh people. Okay. 1 lakh people at a particular time on a day. Okay. For example, at this particular time, 1 lakh people are accessing this Amazon.com. Assume that. Okay. 1 lakh people are accessing this Amazon.com. So this is nothing but the user load. What is this? 1000. That is, sorry, 1 lakh is nothing but the user load. Okay. So what is the user load of the Amazon.com in general? Regularly, the general user load of Amazon.com is 1 lakh users at a time. Okay. And you maintain this user load. Okay. We have tools in performance. You see, before the application goes live, we have to test whether this particular application is able to handle this 1 lakh users at a time continuously or not. Okay. Over a period of time, can it handle or not? We want to find it out. For that, we have different performance testing tools like load runner, JMeter, and all so on. Okay. So in the tool, we will simulate the user load. Okay. And set the user load to 1 lakh. Okay. 1 lakh. We'll set the user load to 1 lakh and hit this and send this 1 lakh user load to this Amazon.com for a period of time. Let's say you want to test it for 1 week. Okay. 1 week. Continuously 1 week, continuously 1 lakh users are using the application. Okay. Over a period of time, one week or 1 month. Okay. Or continuously like 2 months, 3 months, whatever you feel. Okay. For that period of time, with this amount of user load, okay, expected user load for this application, is the application stable or not? It's not crashing. Is it able to handle the load or not? Is it working properly or not? Is tested as part of endurance testing. Hope you are able to understand. Okay, in endurance testing, the application is tested with an expected load. In this case, 1 lakh I told you, right? For a long period of time, it can be 1 week, 1 month, 2 months, 3 months, 6 months, whatever it is, to check whether the application is able to handle that much amount of user load, expected user load for that period of time without breaking, without crashing. Okay, working properly. It should work properly without any problems. That is called as endurance testing, guys. Okay, this is called as endurance testing. So hope guys you understood what is endurance testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 295. That is, what is soak testing? Let me answer. So what is soak testing? Soak testing is a type of performance testing. Performance testing has different types. Okay, we can do performance testing in different types. That is load testing, stress testing, spike testing, endurance testing, scalability testing, volume testing. Where is soak testing then? Other name for endurance testing is nothing but soak testing. Okay, you can either call it as endurance testing or soak testing. Both are same, guys. Okay, soak testing is nothing but the endurance testing. So what do you perform? How do you perform performance testing as part of soak testing? As I already told you, soak testing is one of the performance testing types. Okay, the type of performance testing. But how do you perform soak testing? The application under test is tested with an expected load for a long period of time to check whether the application can handle that particular load for that particular period of time. Okay, what is this? I'll give an example now. Just see here. Okay, for example, guys, there is an application like Amazon.com. Okay, there is an application like Amazon.com. A lot of people access this website, right? A lot of people use, okay, this website. So, roughly speaking, these are not the real numbers. For example, Amazon.com is there. But roughly around the globe, let's say at a time, 1 lakh people 1 lakh users use the application simultaneously. Okay. While one user is using, let's say I'm using Amazon.com now, right? Similarly, as from other place or other machine, some other person is also using Amazon. Like different people are using Amazon at the same time, guys. Okay. Like that different people are using Amazon.com at the same time simultaneously. This many number of users at a time. At this moment, 1 lakh users are using Amazon.com. This is what is called the user load. Okay, expected user load. Amazon.com is an average expecting around 1 lakh users at a time. Okay, so if I have to perform soak testing, which is also known as endurance testing, how it will be performed? this much amount of user load, okay, will be sent to Amazon.com for testing for a period of time, for a long period of time. Okay, so how? You see, it's not real application, guys. Okay, so before releasing the Amazon.com into the market, what software testers will do as part of performance testing is they will they will simulate user load, guys. Okay, they'll simulate. This is not real users. These are not real users. They will simulate the real users. Okay, with the help of the tools like load runner, JMeter. Okay, there is a possibility to set up user load. Okay, there is a possibility to set up user load like 1 lakh users. You can just give the enter the numbers here. Okay, like this you can set up the user load setup and continuously run this expected load for a long period of time. For example, if you want to see whether Amazon.com is able to handle this expected user load for 1 day, what you will do? 24 hours, continuously 24 hours you will check. Okay, you will send this much of traffic to the Amazon.com. It's not real traffic, simulated traffic you will send and see whether Amazon.com is able to handle it properly without crashing, without failing, by working properly, without getting slow, it is working or not, we'll check. So if you want to test for more period, like let's say 1 week, okay, continuously 1 week, this expected user load will be sending to the Amazon.com, and we will see whether the Amazon.com is not breaking, not crashing, not failing, working properly, not getting slow like that. 1 month also, okay, 1 month, whatever the period, guys. Okay, for a period of time, for a long period of time with expected user load, we'll send it to the Amazon.com. Before releasing the Amazon.com into the market, we'll perform this kind of performance testing, guys, and that testing is called as soak testing. The other name for the soak testing is nothing but endurance testing. Okay, so now you can see the this particular line, it will be more clear for you. Soak testing is a type of performance testing. Yes, soak testing is a type of performance testing where the application is tested with an expected load. Okay, expected load is 1 lakh in our example. Okay, for a long period of time, it may be 1 day, it can be 1 week, 1 month, 6 months, 3 months, whatever it is, to check whether the application is able to handle that much amount of load, expected load, for that much period of time. Okay, that's what is the purpose of the soak testing or endurance testing. Both are same name. Okay, the different names for the same thing. Okay, so that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 296. That is, what is capacity testing? Let me answer. So what is capacity testing? Capacity testing is a type of performance testing. Under performance testing, there are different types like load testing, stress testing, spike testing, endurance testing, scalability testing, and volume testing. But where is capacity testing under performance testing? Capacity testing is none other than endurance testing, guys. Okay, it has different names. You can call it as endurance testing, soak testing, capacity testing. Multiple names are there. Okay, all are same. So capacity testing is nothing but endurance testing or soak testing. So in capacity testing, what you will do? Will test whether the application is able to handle the expected load for a long period of time. Okay, so we'll put the application under a expected load that it generally receives and check whether it is able to handle that particular load for a long period of time, maybe for a 1 week or 1 month, 3 months. Okay, we'll continuously send traffic to that simulated traffic, not real traffic, simulated traffic, because we are testing here, right? Before releasing the application into the market, we have to make sure our application is able to handle expected user load. Okay, if the expected user load for an application is 1 lakh at a time, okay, at a time simultaneously 1 lakh people will be using your application, means that 1 lakh user load continuously for a long period of time, like 1 day or 1 week or 1 month or more than 1 month, whatever it is, that long period of time will continuously send the traffic. At any point of time, if you check, that 1 lakh traffic will be there, and the application should be able to handle the traffic, guys. Okay, it should not crash, it should work in a proper way. Okay, it should not get slowed down. Okay, so without any problems, application should run with expected load for which is holded on for a long period of time. Okay, that is what is capacity testing. The other names are endurance and soak testing. So if you take an example, guys, if you take an example of Amazon.com, okay, Amazon.com, and you know that Amazon.com, lot of people will be visiting at the time. At this moment, I am visiting. Similar to me, a lot of people around the globe will be visiting. Roughly, if you take, it's not the real number. Roughly, if you take, if 1 lakh people are going to visit Amazon at a time, okay, at a time, at this particular time, 1 lakh people are doing that. Okay, the application is already live. Application is already live. I am using the application, right, as an end user. So with it's kind of fast, it's working fine, it's not crashing and all. This is all happening because before this Amazon got released into the market, what type of testing was done? Capacity testing, that is either you can call that as endurance testing or soak testing, is already done, guys, where the expected amount of user load, okay, expected amount of user load is sent to this Amazon and tested for a long period of times to see whether it is able to handle or not. Okay, handle or not. This is what is known as capacity testing. Okay, capacity testing. So hope guys you understood what is capacity testing in this session. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 297. That is, what is volume testing? Let me answer. So what is volume testing? Volume testing is a type of performance testing. Under performance testing, we have different types like load testing, stress testing, spike testing, endurance testing, scalability testing, and volume testing. So volume testing is one of the types of performance testing. So what exactly we test as part of volume testing? Software testers, you can specially call them as performance test engineers, will add large amounts of data to the back end of the application. That is to the database of the application. The performance testers will try to add large amounts of data to see whether the application can handle such data or not. The performance of the application is getting affected or not when we add large amounts of data to the backend, that is database of the application or not, is called as volume testing. Okay, you can understand this, right? So whenever a large amount of data is added to the database, that is backend of the application, how the application is behaving, whether the application is able to withhold such large amounts of data or not. Okay, whether the performance of the application is getting affected or not, is the application getting crashed or is able to load such kind of data, what is the speed at which the application data is getting loaded, whether the application is getting crashed due to that large amounts of data. All these kind of things will test as part of volume testing. There is another name for volume testing, guys, that is flood testing. So hope guys you understood what is volume testing, which is one of the types of performance testing where large amounts of data will be added to the database of the application to test whether the application can withhold such data without impacting the performance. So that's all for this session. The next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 298. That is, what is flood testing? Let me answer. So what is flood testing? Flood testing is one of the types under performance testing. Performance testing has different types like load testing, stress testing, spike testing, endurance testing, scalability testing, and volume testing. Volume testing is also known as flood testing. Hence, flood testing is one of the types of the performance testing. So, what will be tested as part of the flood testing? In flood testing, the software testers, that is, especially they are known as performance testers, will add large amounts of data to the backend of the application, that is, to the database of the application. The performance test engineers will add large amounts of data to see whether the application is able to withhold that much amount of data and handle the performance properly or not. Whether the performance of the application is getting affected when to the backend this much amount of data is added. Okay. Testing that is called as flood testing. In flood testing, large amounts of data will be added to the database, that is backend of the application, to see whether the performance of the application is not, okay, not impacted. Okay, so what is the performance of the application when large amounts of data is added to the back end of the application, that is database of the application, is called as testing, that is called as flat testing, okay, or how much amount of data the database of the application can handle, okay, can handle without impacting the performance and okay, and is working properly without impacting the speed and etc. is called as flat testing. Okay, there is other name for flat testing, that is nothing but volume testing. We can also call that as a volume testing. So hope guys you understood what is flat testing in this session. So that's all for this session. In the next session I'm going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all. Welcome to this session. In this session, I'm going to answer software testing interview question 299. That is, what is spike testing? Let me answer. So, what is spike testing? Spike testing is one of the performance testing types. Under performance testing, we have different types like load testing, stress testing, spike testing, endurance testing, scalability testing, and volume testing. And spike testing is one of the performance testing types. So, what exactly is performed as part of spike testing? So, the software testers who are specialized as performance test engineers or performance engineers will suddenly increase or decrease the user load, that is traffic, at extreme levels on the application. Okay, so if you take any application guys, for example if you take an application like Amazon, okay, let me explain in a better way. Let's say we have amazon.com, right? So amazon.com generally receives, assume that, okay, randomly, it's not a correct figure but I am just taking an example. Let's say amazon.com is daily receiving 1 lakh users, okay, at a time 1 lakh users are visiting amazon.com, let's assume. Okay, this is a general user load that amazon.com receives. But as part of spike testing, what we do is we suddenly increase or decrease this user load at extreme levels. So instead of 1 lakh we suddenly send 3 lakhs and check what is happening. Sudden spike will, okay. So this is a simulated traffic, guys. It's not the real traffic. Before the application is released into the market, we perform spike testing, a type of performance testing on the application to see how the application is going to handle this user load. If the application is capable enough to handle 1 lakh user load, then what if 3 lakh user load is sent? What is happening with the application? A sudden spike. Suddenly from 1 lakh you just increase the user load to 3 lakhs or decrease also at the same time. Okay, instead of sending 1 lakh you are sending something like 25,000 user load. Okay, so what is happening in that case? Okay, how the application is able to handle it, whether the application is crashing or whether the application is becoming slow, what's happening, is able to withhold the traffic or not. Okay, despite of getting lot of traffic than expected, whether the application is able to withhold or not due to this sudden extreme increase in traffic or a sudden extreme decrease in the traffic levels, that is user traffic levels. What's happening to the application? That testing, okay, which is performed before releasing the software into the market, is known as spike testing, guys. Okay, is a type of performance testing where sudden extreme increase or decrease of user load, that is traffic, is done on the application to check how the application is behaving and performing. Okay, application is behaving performance wise under these conditions. Okay, so under extreme conditions of the user load, how the application is behaving, checking that is called as spike testing, guys. Okay, so hope guys you understood what is spike testing. So that's all for this session. In the next session I am going to answer another software testing interview question for you. Till then, see you. Bye bye. Hello all, welcome to this session. In this session, I am going to answer software testing interview question 300. That is, what is scalability testing? Let me answer. Scalability testing is one of the performance testing types. Under performance testing, there are different types of testing like load testing, stress testing, spike testing, endurance testing, scalability testing, and volume testing. Hence, scalability testing is one of the performance testing types. So what exactly is tested as part of scalability testing? So in scalability testing, which is a type of performance testing where we test the flexibility of the application to scale up in proportion to the increased demands of the user workload. When user workload, okay, number of users who are visiting the website or application increases proportionately, whether the application is also able to scale up or not. Okay, so what do we do is, you see, let's say you started a website. Okay, for example, in real world, let's say you started a website. The website initially was getting 1,000 users. Okay, was getting 1,000 users, and the performance of the application is good. So every day 1,000 users are coming to your website, and the performance is good, guys. No problem. So you started putting more content into the website. Let's say after a period of time, maybe after 6 months or 1 year, what happened was, instead of getting 1,000 users, now your website is getting 2,000 users or 2,500 or 3,000 users. So now what happens is, you think of, okay, my application can handle 2,000 or 3,000 users because it was earlier handling 1,000 users. Now 3,000 users are coming to your application. So you may think of increasing the server space, CPU, RAM, and all those stuff. Okay, wherever your application is hosted, right? You'll upgrade the plan so that the hardware and software get upgrades, scales up according to proportionate to the user traffic that got increased. You have to upgrade your plan, hosting plan or whatever it is. Okay, so that the infrastructure, okay, will be increased, and automatically that many number of users can be handled by your application. But whether that is happening or not, we have to check. Despite of despite of increasing the size or volume of the system to meet the user workload needs, okay, whether the application is able to handle the performance or not. You already increased it, guys. Okay, for example, instead of 1,000 users, if you are getting 3,000 users, so you scaled up your machine. Okay, wherever the server you put your application code, right, that server machine you upgraded to the next level. Okay, the old server you from the old server you deployed the code into the new server, where it can have more data space, more speed, okay, more RAM and all those stuff. Okay, you already increased, you scaled up the system. But just by scaling up the system, you cannot assume that it can handle, instead of 1,000 it can handle 3,000. Okay, because there may be some problem in the application logic, because of which, despite of you scaling up the system, it may not handle that much amount of traffic. Okay, so to overcome this problem, to identify the problems in advance, performance bottlenecks in advance, we perform scalability testing to see if, okay, so if I increase or scale up my system where my application is hosted, whether it can handle the increased levels of user load or not. That testing we perform in advance. Okay, before releasing the software into the market, expecting that there may be some there may be increase in the user load at some point of time, whether my application when scaled up can handle that user load or not. Okay, that is what is scalability testing, which is one of the types of performance testing. So hope guys you understood what is scalability testing now, right? So this is what is scalability testing. When changes are done in the size or volume of the hardware system or software system to meet a user growing needs. Okay, is it happening or not? Is checking is nothing but scalability testing. So that's all for this session. In the next session, I'm going to answer another software testing interview question for you. Till then, see you. Bye bye.